Okay, cool. That's cool though. I didn't know that you can do that. I'm gonna learn. I'm gonna teach myself something new now. Oh, I see how I can do that. Okay. So when you get your home energy bills, when you guys get your electric bill, it listed in kilowatt hours. Okay. But when you go to the grocery, when you go to the stores, you see things like 12 watt light bulb, you see 9-volt batteries, you see vacuum cleaners that are like 15 amps of sucking power. So what do these numbers mean, right? Well, there's a lot of different functions to electricity in order to be able to make sure that when you push a button, your lights turn on. And it's because several important things need to happen in an electrical circuit in order for electricity to flow and for the work to be done. So check it out. It works just like this. You can kind of think of your circuit like a faucet on your kitchen sink. If you want the water to come out, you need two things itself in order to make sure the water is coming out. First, you need the pressure to force it through the pipes, right? And you need the water itself. So the water would be the electricity, right? And you need the pressure in order to make sure that it's pushing it through. Now, an electrical circuit uses electrons to carry the electricity through. So kind of like the water in your faucet, but the electrons need something to push them along the circuit. So this is where our first definition comes in, voltage. So what is voltage? Voltage is a force associated with an electric current that is measured and known as volts. Power companies use high voltage to move electric power over long distances. This electrical pressure is what we call voltage and is often provided by two terminals, one with a positive charge and one with a negative charge. Give you guys a second to write that down. So I'm going to show you guys the easiest part of the definition on this one, because I actually narrow these down to just the whole definition to one word. This is all you guys are going to need to know. So it looks like a battery. Voltage equals pressure. So write that down. It might be on your test. If you hear the word voltage, what are we talking about? We're talking about the pressure for the electricity, right? That the electrons are going through. So we're talking about pressure. Okay. Electrons flow from the negative through whatever you're trying to power and then end up at the positive end where they stay unless your battery is rechargeable. Okay. So I actually have a little GIF that shows this later, but all the actual power is going to be stored on the negative end and it goes to the positive end and it stays there. If your battery is rechargeable, then it brings the power back down to the negative end so it can continue that circuit after the fact. Okay. That's the differences between them. There's a couple other things that go along with batteries that we're going to talk about later in the storage section, like DOD, depth of charge. What happens if you go over the depth of charge and all that other stuff? Don't worry about it right now. Don't worry about writing that stuff down. Just letting you know, just in case because that question comes up when I talk about this after the definition section. We will cover that other stuff later with batteries. Okay. So this is just a good example because we've all used batteries in our remotes, right? We have a positive, we have a negative. If it's put on the wrong side, it's not going to power it the way that we want it to turn on. So this is why it's designed in that circuit. So if you're plugging something into the wall, this voltage is instead provided by the power company. They're using high voltage, a lot of pressure to get that electricity to your house. Although voltage is measured, although voltage just measures how strongly electricity is being pushed through a circuit, it's important because many circuits are designed only to accept a certain number of volts. So if you put something in that's too high of a voltage, what's going to end up happening to the circuit? Pop a circuit, right? Blow a breaker. Stuff like that happens. That's why we have things like surge protectors now, which weren't available that much back in the 80s. And we saw a lot more house fires than we do today, right? So there's a couple things that go along with that. Not having the right voltage, not having the right pressure, not having the right current, not having the right resistance. There's a lot of things. We're going to learn all about all those today. Okay. So a couple things you guys might need to know for your test. Number one, voltage equals pressure. Number two, the power flows from the negative to whatever you're powering and then stores all that back in the positive if it's not rechargeable. Okay. Next one, amps. Amp is short for ampere, not for amplifier. Okay, just in case there's any musicians here that were curious. Which is a unit of electrical charge is flowing past a given point in 1 second. So when you put volts and amps together, you can tell how much current is flowing and how hard it's flowing. So current is the flow, which helps manage the current. Okay, so that's what amps are. I'll do something real quick for you guys. Ooh, what happened? I pushed the wrong button. Give me 1 second, guys. Sorry. How do I get it back? Here we go. Push the wrong button. That's my fault. Okay, so now that we understand that amp equals flow, that's where we're at. So amp equals flow. So here is the power formula. If we want to figure out what the watts are, which is what we're trying to figure out in our job here with solar, we need to multiply amps times volts. So flow times pressure will give us the amount of watts that we have. Formulas will not be on the test. It's just good to know. So when you put volts and amps together, you can tell how much current is flowing and how fast it's flowing. So let's take an example, okay? Give you guys a second. If I do move too fast, just unmute yourself and say you're moving too fast, okay? So let's suppose you hooked up a water wheel to a generator. So a water pistol that forces the water through a small nozzle, the total volume flowing per second, it's not very much, right? There's not a lot of water being pushed through, but it's a lot of high pressure. So the water comes out very, very strong. Let's say it's enough to go ahead and turn that wheel. Okay. Now let's take it with a wider hose. This time, instead of the water gun, let's use the wider hose. Even though the wider hose doesn't push out the water as strong, more water flows per second, the wheel ends up spinning at the exact same speed. Does that make sense to everybody? So we can have the same amount of wattage that comes out without having the same diameter of hose or the same pressure, right? So if we think of the water hose and the water gun pushing out electricity instead of water, we could say that at the end of delivering the same number of watts. Okay. So here's an example for electricity, and we're going to use the power formula. We're actually going to use it in reverse this time. So let's say you have a computer with an 1100 watt power supply, and it's running full load, and you're in North America, and our outlets out here are 110 volt, right? So we know our pressure is pushing through at 110 volts. We need to figure out if this is going to be able to turn on in England as well. So we know right here that we have 10 amps. So we're going to take, instead of multiplying the volts times the amps to get the wattage, we know the wattage and we know the volts. So we're going to divide the volts or the wattage by the volts. Okay. We're going to end up with 10 amps. So if we want to test it in Europe, they have a 220 volt outlet. We're still going to end up with 5 amps. Okay. So our flow is going to be less, right? However, because the watts are the same, the computer will work in both places. Even though the volts and the amps are different, we still get the same wattage. All that matters for that computer to work and turn on is the amount of watts. It's not about the flow and it's not about the pressure. We need the wattage, not the voltage or the amperage to make that stuff work. So when you're taking a look at stuff like the 15 amps of sucking power, we need to figure out the amperage. It has to have the right amperage in order to be able to make that work. Does that make sense? So for your house, we need watts in general to get the alternating current to the right portion so we can get that in there so you're good to go. That's where AC and DC and alternating current and direct current come in. I know we have a project manager back here who understands a lot of that stuff. Right? Have I lied so far? Shelly, have I lied so far? Nope, both Isaiah and Shelly. We got two solar people in here who tell you they both got a lot of experience. They'll tell you if I'm lying to you about anything. Okay. So here is a couple things we got to make sure we have. So first, the voltage is the pressure, right? Voltage is the pressure that pushes the water through the hose, and it measures usually in volts, or you can see the V. Okay. Current is the diameter of the hose. It's the wider it is, the more water is going to be flowing through it. So we usually measure that in amps, which is the flow, right? That's going to be measured in the I or in the A. And then resistance is like sand in a hose, which slows down the water. It measures in ohms. So that's where we have this symbol, or we can use the R. So resistance could also be like kinking a pipe, right? If we have a hose and we're trying to walk from one part of the yard to the other, we're going to kink the hose. We're going to cause some resistance. If we're trying to get it to go further, we can put our thumb over it to cause some resistance and be able to push the water out a different way, right? So we can actually make those adjustments on a water hose. So that's what the resistance is. There's not too much to go into with that. It'll make more sense when we're talking about solar panel shading and stuff like that. That was tough, right? Any questions so far about anything we've covered so far? Nope, I think we're good. Give everybody 10 seconds just in case they come up with some. All right.
I do, since we're on wattage. What is our standard wattage of our main panel?
220, 200, 220. So we're going to do without an MPU, as long as we have available spaces, 200 amp is going to be more than fine. And then for the main panels, what you want to know for the wattage, we should.
Yeah, our main panel.
I haven't looked at it lately. Brian has that info.
That's okay. It'll come up. No big. We'll get there.
It's a good question. I know we're at 200 amps, 200 amp for the main panel. And that's all we need. And that's all we need.
And then we're going to cover degradation and all that.
Are you talking about for our solar panel?
Yeah, the solar panel.
400.
Thank you.
Yeah. 400
and which is that, the Titan panel?
This one's the Honeywell Q cells. Silfab was Silfab was, they didn't have enough stock, so we're using the Honeywells now.
Okay.
I know David's trying to get those white labeled as well. Any other questions? So photovoltaic solar. So guys, we're gonna learn a couple of things in this. Number one, photovoltaic and solar. What's the difference? Well, if you hear the word photovoltaic, it's talking about solar. First part of the definition. So you're going to see things like PV system. You're also going to see things like photovoltaic solar system. It's all solar. On solar contracts, it all goes back to, it all says photovoltaic, or it says solar, or photovoltaic or photovoltaic module. Module is the panel, so all it means is a solar panel. I don't have a bunch of slides on that because it's super simple. If you see photovoltaic, we're talking about solar. Simple enough. I'm going to add an equal sign in that. I think it's going to make it easier. So let's talk about kilowatt hours. What are kilowatt hours? So is kilowatt hours a unit of time? Absolutely. No, scientists hate us. It's not a unit of time, even though we say hours. It's a unit of energy. Okay. Might be in a test. Yeah. So kilowatt hours are not a unit of time, even though it has the word hours in it. Do not let it confuse you. It is a unit of energy. So let's talk about it briefly. So watts and kilowatts express how much energy is consumed per chunk of time. This is called power. This is not the same as energy. A watt is an amount of electricity, of energy in joules. Then an electrical device such as a light bulb is burning per second that is running. So a 60-watt light bulb is burning at 60 joules of energy every second that you have it turned on. You won't need to know that part. This is what you need to know. So kilowatt times hours equals energy in joules. So now that you guys know that part, it'll help explain this part a little bit better. A kilowatt is a measurement of power.
Sorry, can you go back for just 1 second?
Yeah.
Sorry, thank you.
Wait, what do you mean like in energy in joules?
So that's the actual formula itself. You're not going to need to know it for your test. It's not going to need to even come up. The next definition will help you guys understand a little bit. Okay.
Thank you.
So a watt is just the amount of energy, and that's all it is in joules. So it's just another unit of measurement for electricity. Okay. Which is also just, we just refer to it as watts. It's actually part of the training I'm considering taking out because it's not relevant to your guys' job. It was something I built for the installers, because as a project manager would know, the installers need to know that part. There's a lot more involved with that. This because I have this training for installers, and it's way more in depth than what you guys are going to learn. Okay. They see the same slide. So don't let it confuse you. The only thing you'll need to know is that kilowatt hours equals energy in joules. It's the same thing. So if you're ever sitting with an engineer, it's the main reason why I kept it in. So like, well, what's the energy in joules? Well, it's your kilowatt hour. It's your kilowatt times your hours. So which equals your kilowatt hours. So check this out. This is what they're talking about. I have had engineers ask me that question. It's like, no, we're just trying to figure out the kilowatt hours. And they go, oh, okay. And they're just trying to test you. So this is all you do to refer back to it. A kilowatt is a measure of power, while a kilowatt hour is the length of time that something can use a kilowatt. That is basically the definition for the energy in joules, how long it's burning. So like that 60-watt light bulb is burning for X amount of time. That's the kilowatt hours. 1 kilowatt hour is equal to 1,000 watts sustained over 1 hour. PV solar systems, or photovoltaic, or just solar systems, might need to know that for the test. PV and photovoltaic are just longer scientific terms for solar. Sizes are calculated in kilowatts. The system size, or the size of the system, is determined by how many kilowatt hours need to be produced. We're going to go into more detail about this later. So there's going to be some of the stuff where it's like part of it's talked about now, but I talk about more of it later. So when it makes more sense, after you get more of the actual. So guys, also, if you guys ask a question and they say we're going to cover that, don't stop that from asking more questions. Okay, just not about that part. That just means I'm going to cover it and it'll make more sense later. Okay.
So Chris, when you're in somebody's house, I mean, we used to literally call TEP and ask them what their kilowatt hours were for the entire 12 months.
Yeah.
You guys do that, don't you? You don't use just one
TEP
deal.
closed that department. They closed the back end office for it.
They won't answer that?
No.
Okay, well, you know what? It
You
used to
have
be
to be on the
the,
phone with the customer now. The customer has to get it. They can't even speak directly to you anymore with TEP.
yeah, I used to do that with the customer, or I used to be able to, they used to be able to get it if they had an online account through TEP,
can still
and I
get
would
it
direct
online.
how to get it.
Yeah.
So
you
they can
still-
do that if they have an online account, or we can make an online. Yeah.
But if you call, it's actually all utility companies got rid of all their back offices. You cannot call and ask for a customer's kilowatt hours anymore. All utility companies nationwide have gotten rid of that. About, I think it was end of 2019.
Okay, but you still do get the customers to get it, because obviously you don't just go off
Have to
one
have it.
bill, right?
Yeah.
It's
Yeah.
that
We're
way.
on, tomorrow, we're going to go in depth about how to get that. And if they
Okay.
don't have it, what to do if you can't get it right away, and then how to submit it back when you're inside the house so that you can get a correction on a proposal.
Okay.
Cool. So is that. So the PV system generates power from the panels, converts DC to AC at the inverter. Then it uses that to power the home. Excess power generated is sold back to the grid in the form of bill credit. The system stops when the grid is down. If you do not have a battery backup, there is no such thing as trickle power. I've been hearing more and more and more of this from other companies. They say, oh no, if the grid goes down, you might have trickle power enough to just like keep the fridge on or maybe your lights if you have solar. It is a bull-faced lie. It is the biggest lie you could ever tell your customer, and that is no. The answer is no. I actually bring it up now because none of our reps have said it, but they've heard it in the house a bunch of times. So we've been getting questions. Somebody said it and all of a sudden it became a thing. If they do not have a battery, if it is a solar only system, which is about 90% of all solar systems sold are solar only. If the grid goes down, there is no power to the home. You guys learn more about rapid shutdown through the inverter section in a little bit, and why that happens, but quick, simple answer. And this is actually, I used to do through Solar Coach. It's one of the questions that used to come up all the time is we used to answer it all the time during monsoon season. Chris, what would happen if the grid went down during the monsoon? Well, that's a fantastic question. Because power is fed back to the grid, a rapid shutdown is going to happen at the inverter, which is going to keep power from being sent back to the grid. So first responders and electrical workers can work on the grid safely. You can't send power back when they're trying to fix something. It's like keeping a breaker on in the house when you're trying to stick a fork in electrical out, like to get the other fork that the kid broke off in there. That's exactly what happens. So if they don't have a battery, the answer is absolutely not. The power will go down. That doesn't stop customers from buying solar. I've never had a customer not buy solar because of it. Just be honest. Really quick section on photovoltaic solar and does the system go down? I want everybody to mute themselves real quick. I'm going to give you guys all 10 seconds to unmute. I'm going to ask you guys one question and I want to see if everybody gets it right. True or false? My solar only system, I have a solar only system. The grid just went down. Am I going to have power?
No.
Power. No.
No,
No,
No
I'm
way.
not going to have
Yeah.
power. I can't say that one enough.
You're gonna kill somebody.
Yeah, that's exactly what would happen.
yeah,
That's what you guys are gonna learn about string inverters and micro inverters and optimized systems and all this stuff and why and what and how. And I got a very in-depth section. So you guys are gonna start to notice that these start out very short before the question periods, and then they start getting longer and longer and longer and longer by the end of this training. You guys are gonna get through all the definitions today, and then we're gonna start tying them into how to explain that stuff. And yeah, it's gonna be good.
We don't even sell string inverters, do we? Good. Thank
Solar
you.
Edge is a string inverter. It's just got an
Okay,
optimizer on it.
You know,
Yep.
they don't work so.
I want a standard string inverter. Absolutely not. Never. I would never sell one of those. When it was an adder, I used to pay the adder just to get it on there. I would rather not. I would never sell a string inverter. Anybody have any other questions?
We do offer power walls, backup batteries, and okay.
Powerwall, LG. So the LG Chem does not exist anymore. LG is out of the solar game completely as of
Okay.
2.5 weeks ago.
But isn't it
Okay.
better if you offer a generator instead of a battery?
So we do, yeah, we offer Generac for the generators and for battery backups as well. So they have battery backups too. The Powerwall is actually going to end up being a lot cheaper. We have some words that are coming down, and they're going to announce their new Powerwall, which should be
Okay.
less expensive with better storage capacity. So as soon as Tesla announces that, you guys are going to get a training on the new Powerwall.
Yeah, I'm familiar with the Tesla ones, but that's about it.
Yeah, it's pretty much the only ones that are worthwhile right now because of all the smart safety features, smart features that are in it.
Yeah,
Everything
yeah.
else, it works. It's better. It's not as good for home use, time of use, grid charges, all that other stuff. So you guys will learn. You guys will learn something pretty cool today about batteries that I don't think even people who've sold Powerwalls before even really know. So there's some cool stuff. Any other questions about what we covered so far?
No.
Cool. Let's do this.
this is all gonna be safe and recorded.
What's that?
No, I said that you're recording all this stuff so we can go back and review it.
Yeah, I actually have another playlist just in case this one gets corrupted too. So
Okay,
yeah, tonight they're all going to be sent out. So You guys will have
Okay.
access to the whole week ahead of time. If you
Mhm.
want to go, doesn't give you an excuse not to show up for training. So just because you have it doesn't mean you can't just show up. But if you want, you guys can watch it at your, at your leisure and then come to training and know a little bit more.
Okay,
Cool.
sounds good.
All right,
Mhm.
let's do this. Azimuth. So first big definition that we're going to learn is azimuth. It's super important to know. It is actually something you guys are going to have to explain to your customers. So there's going to be multiple points of this definition that you guys are going to need to write down. I'm going to give you guys plenty of time to be able to write down the definitions. I kept the closed caption on for that reason. It's better. So what is an azimuth? It's the direction of the solar panels from the observer expressed at the angular distance from the north or south point of the horizon to the point at which a vertical circle passes through an object that intersects the horizon. Let me make it simpler for you. If I have this line, that's what the azimuth is going to be in degrees. So if we have a circle, we're going to be at 0 or 360. It's the same thing. We just do 0, 90 degrees to the right, 0 to the left, or to the bottom, or 180 to the bottom, and then 270 to the left. Or 45 going this way, 135, 225, 315. To make it even simpler, it's a compass.
You don't mind going back just so I can read something real fast?
Yeah, you're not going to need it. I promise you. All
Got
it means is that what direction the panels are going to be facing. So what does it mean for solar? This is what it means for solar. The direction of the panels directly impact the production of the panels. So if we take that same little cross that we had before and we put it at a north, we're looking at 0. So north is a 0 azimuth, south is a 180 azimuth, east is a 90 azimuth, west is 270, northeast is 45, southeast is 135, southwest is 225, 315 is northwest, and then all the points in between, all the way up until 360, which resets 360 goes to 0. Okay.
Your software automatically does that, correct? I
Yeah.
mean,
I'll show you why you guys need to know it, because it's how it's built on the proposal for you guys to know and what points come up. Okay. So here's the thing. So the ideal azimuth for peak production is 180 degrees or due south. From sunrise to sunset, the solar panels receive the optimal amount of sunlight to produce the required kilowatt hours. This may vary depending on the consumer need. So let me explain this to you guys. If the optimal is 180 degrees on this roof, well, these are blocking my south facing roof. I still have a small section here. So if I put a couple panels here, but I put a couple panels over here, I'm actually going to need a few more to create the same amount of kilowatt hours as I would on this roof. I'm going to go into more detail in a minute. Okay. If this wasn't here, I could probably put all the panels right here and reach just fine. We don't want to be on a north facing roof. Solar panels need direct sunlight to be able to produce the most power and for them to work at their peak efficiencies. So when mixing multiple azimuths, the factor changes and requires a higher kilowatt system to produce the same kilowatt hours. So I'll give you guys a second to write that down, because I'm going to explain how that works here in just a moment. Now, this is going to be really important for when you guys are working with customers on referrals or selling multiple neighbors on the same street. Okay. It's always going to come up. This question will happen a lot, and it's not an objection. So this is what I talk about when I say we don't have a lot of objections here, because we have answers. As long as the customer is informed, there's no objections. I don't receive the objection. I need to think about it or do my own research, because the customer does their research with me. I am their source. They ask me their questions. They trust me to answer their questions. Here's why you guys need to know it. Check this out. Look at the map. If you guys pulled up maps on your phone right now, Google Maps, Apple Maps, whatever the case may be, when you're looking at it from the observer position, where top is north and bottom is south. So 0 and 180, 90 east, and then 270 west over here. Okay. So if we look at these panels are facing east. These panels are facing southwest. These panels over here are facing southwest, slightly more south or slightly less southwest in this system, right? So here's another one that's facing slightly southwest. And I'm going to make sure that we break this down slightly. Okay. So here's a true satellite view of some roofs out here in Southern Arizona. Let's determine a couple azimuths of these homes together, and we'll figure out why this is so important. All right. So let's say we're looking at this home. So first we got to pull up our compass, right? So we know that we're looking from north to south, east to west. If we look at this home right here, it's at a 275-degree azimuth. All right. So it's slightly more northwest than it is facing west. And then over here on this side is slightly more southeast because of that. So it's 95. It's only a 5-degree difference on the two. Here's why this is so important. If you're doing a system size for this customer here, and this customer over here bought electricity or bought solar, but their electric bills prior to getting solar were exactly the same. Well, unfortunately, this customer is going to need a bigger system because their roof slopes in different directions. So the panels are going to be facing from east to west. Same thing over here. These customers wouldn't have the same system sizes, even though they have the same utility bills. All right. So right here, let's say you have Joe, and then his sister Diane is right down here. Okay. When you were selling Joe, he asked the question, hey, why is my, let's say, let's talk to Diane. All right. So Diane says, where's the bigger system? That's the biggest one I got. All right. Well, whatever. About the same system sizes. So Joe says, hey, my sister Diane just bought solar from me a couple months ago, and her system size is a lot smaller and it's a lot less expensive than mine. Why is that? Well, Joe, here's the deal. So you can even pull it up on the map. So your sister's roof is facing more south. She's got almost a perfect roof for solar. So from sun up to sundown, those panels are getting more direct sunlight on it. On your roof, you're getting a lot of direct sunlight in the first morning part of the day, but towards noon, the west side of your roof receives all the direct sunlight, while the east side of your roof has indirect sunlight. So really what happened here is you're looking at a system that probably could have produced a little bit more power if they were done on east to west, because of how much indirect sunlight is going to be exposed on these panels during over half of the day. So here's the moral of the story. No two system sizes are alike. So if we took a look at this roof over here, they're at 225. This roof over here, they're at 170. These two systems wouldn't be the same. Hey, you just pitched Bob, and Bob is going to need a much larger system than me. Are you trying to rip my friend off? No. Here's the deal. We need to put more panels on him to create the same amount of kilowatt hours. And I'm going to show you guys how the kilowatt hours are built so this makes more sense. Okay, or how the kilowatt system size is built and how we determine the kilowatt hours. But he's going to need more panels to create the same amount of kilowatt hours because you have direct sunlight from sun up to sundown on your roof for most of the day. Maybe during the end part of the day, you don't because you're not facing directly south. But yeah, your buddy over here, he's got less direct sunlight for more than half the day. So we need to try to produce all the power right when his from indirect sunlight, and then get the rest of it during the direct sunlight portion. So some more of this stuff, again, this is broken down into sections and definitions. Now that you know that, first of all, the panel, the way the panels face will directly impact the production of the panel, which is the azimuth. Two different azimuths are not going to produce the same as one azimuth. So, and no two system sizes are built the same because roofs are generally very different, not including all these other things that we're going to talk about. I'll show you guys how this works in the mathematical sense in a little bit. Okay. So This will be one of those where you may have a question. Feel free to ask it. I will tell you if we're going to cover it in a little bit or not. And if it's not something if it's something that's I can answer now, I will answer it now. I know that can be confusing for a lot of people. That's okay.
Will we be responsible of designing these arrays? Okay,
But you need to understand how to tell the customer, right?
good, okay.
So hey, you got a great roof for solar. This is going to be great. So even if it's east to west, it's still a great roof for solar, right? If it's a south facing roof and there's all kinds of stuff that's just blocking it, we can't install on it. And it's going to be a north facing roof. So you have a roof that can have solar on it, right?
Right.
It's going to work, but it's going to be a larger system size than maybe some of your neighbors. Here's the reason why, because nobody else that gave them a proposal before made sure they understood that. There was actually a direct quote from Matt, who the VP of sales over at Titan. He's the one who works with all of us. He's our contact point for the installation. He said, "There's not a single salesperson that understands azimuths." Brian and I both laughed. All of our salespeople know what an azimuth is. Okay, like it takes a lot. Like you actually have to learn you have to be in the industry a while to actually learn what that is, and it sucks that you do. But for us, you guys learn day one. Any other questions? Cool. So it's going to make more sense as we continue on because all these things end up feeding together. Tilt is another one. So this one can get confused with azimuth sometimes. They are not the same thing. So I need you guys to understand that. So you might want to write a note that says tilt and azimuth are not the same. Azimuth is the direction of the panels, and tilt, oh, you're good. And tilt is the angle of the panels. So the tilt of a solar panel is also known as the pitch, which will impact the amount of the tilt towards the sun for the PV array. Most arrays are flush mounted, meaning they follow the same pitch as the roof itself. But they're raised a few inches above the actual roof itself for access to it and airflow and all that other good stuff. Okay, so they're not completely just mounted onto the roof. There is a few inches of space in between, but they follow the same angle as the roof itself or the slope. Okay. If the roof is flat or nearly flat, it may be desired to tilt the solar panels on the roof to achieve the optimal angle towards the sun. So this is another factor that we have on the back end when we're designing these systems to make sure that the angle is actually going to be right for the right time of year to produce the right amount of power. So I'm going to explain that more here in a few minutes. So I'm going to give you a few seconds to write that down. Yeah.
Chris, wouldn't you put brackets on any flat roof? I mean, you don't want those panels directly on that roof.
Correct. So we usually do flat roof or we do open systems on those, but there are a few customers in the past who have said, yeah, we just want to go completely flat. Okay, cool. But I'm going to explain it. It's actually one of my, there's actually slat on it. I've had a couple customers who've been like, I just want it completely flat. Okay. But just so you know, I'm going to have to add extra panels. I don't care. I want it flat. Okay.
Okay. Why? But okay.
It's just aesthetics for some people.
Well, they typically have that edging around any flat roof. You typically can't see them because, you've got a wall, you've got that retainer wall normally.
Yep.
But okay. Okay. Gotcha.
No, you're right. I got a whole section on it. Trust me. I'll show you. Give you guys another couple seconds to write that down because it's super important that you understand that part.
Chris, so
Yeah.
tilt is so azimuth is the angle and tilt is the what again?
So azimuth is the angle towards the sun, like which way the panels are facing. Tilt is the angle of the panel. Okay, so azimuth is where they're facing. Tilt is the angle of the panel itself.
Okay, thank you.
You're welcome. So just think of azimuth with the compass. And then tilt is going to be, I'll show you guys examples. So once you see the examples, you'll understand that part.
Okay.
And keep it up for another 5 seconds. Okay. So does location affect my tilt? Write this down. It may be on your test. Yes. Geographical location is a major factor in determining the tilt of a solar panel. Because the Earth rotates around the sun on a tilted axis, higher latitude areas farthest from the equator will yield lower levels of production. Just like it's possible to get sunburn on a cloudy day, solar panels can produce energy even from indirect sunlight. But indirect sunlight doesn't create the most energy, right? So let's take a look at our little graph here. So if we have this nice, big, bright red area, that's going to be the most sunlight, most direct sunlight we can get. This is going to be right here. If you live in these areas, you know we're not lying. Okay. Then if you look over here, well, these have a different, because of because of where we're at on the equator here, you're going to see different yields for the sunlight. So the part that you need to understand is, does location affect my tilt? Yes. You guys will not be building these systems. You guys will not be building the tilt. You guys will not be building with the azimuth. We do it on the back end. But if a customer asks, well, can I just lay it flat on my roof? You can, but we didn't design it that way for your system because of where you're at or because of the pitch of your roof. So check this out. So the tilt, so the type of roof also matters. So ask this question. This might be on the test. Does the roof type matter? 100% yes. Depending on the part of the country, builder, or even personal preference, there are different roof pitches that can and will directly affect a solar installation. This will directly impact the tilt of the solar panels. Conventional slope roofs are most common with residential roofs. This means the slope has a pitch between 412 and 912 on most homes. Roofs with the pitch exceeding 912 are called steep slope roofs. So here's what we're talking about. Anything above a 912, so 1012, 1212, these are going to be like church steeples. We don't install on these. You can't even walk on them. Okay. Anything below that, it's uncomfortable to walk on an 812, but we can do it. All right. Newer homes are all 612. Most homes have a 412. And then this would basically be a flat roof. It goes down to a 112, which is more common down here in the Southwest where Shelly and I are. So this is what she was talking about. I'll show you guys what the retaining wall and parapets look like. Because if you're in some other parts of the country, you don't have those. You just have a normal flat roof. Here's why it matters. Okay. And you guys are going to see how this works here in a second. If we need a tilt, so this is about 45 degrees. Okay. So let's say, hey, we need a 20 degree tilt. Well, we can't exactly just take a hatchet to this roof to put the panels in there, right? So we're just going to lay it flat on the roof itself. Here, we might need a 45 degree, which means it would be angled up like this. Okay. So it looks something like this. This is what the tilt looks like. We've all seen solar panels that have something like that on a roof when we drive by it, right? We can do it to where we face them 180 and get the azimuth directed that way, and then have a different type of racking system and do a reverse tilt and all kinds of stuff. We don't like to do it because it can affect wind loads. It can affect permitting, and some finance companies won't even finance that system anymore because of the risk it causes to the roof and to the installation itself. But how do we fix production? Adjusting the tilt can help compensate for losses based on geographic location. By adjusting the angle of the panel, the amount of direct sunlight can be controlled. For solar panels to get their best performance, a steep angle of 60 degrees is best during the spring. The best angle is 45 degrees, and during the summer, when the sun is at its highest in the sky, you want to have a tilt below 20 degrees. Because solar panels are mounted on the roof, it's important to determine the best angle for year-round production. So we want to figure out based off the customer's usage. So more than just how much electricity they use on kilowatt hours is important. This is why we have the satellite images, and we have some really cool tools that let us see the side of the house, the tilt, the angle, or the slope of the roof, the pitch of the roof, shading areas, so we can see what's going to affect the actual installation and start designing the system the best for the customer. So I'll give you guys another 10 seconds to write that down, and then I'm going to move on to the next one. This is a flat roof install. Okay. These are my favorite installs, to be honest with you. It costs an extra couple $100 for a customer to get a flat roof install because there's a different type of racking that's involved. But we can control basically everything about a flat roof. It's the easiest one to get the most production out of it. So check this out. Installing solar on a flat roof requires a different type of racking system, an offset of at least 3 feet, and adjusting the panels to the correct tilt. The largest benefit to a flat solar of a flat roof solar is the system can be installed in virtually any azimuth with any tilt. Solar panels will cast a shadow behind them because of their angle. To avoid creating shade, it's on the rest of the equipment, the correct distance between the panels is necessary. Too close and the shadow could affect production. Too far apart and you reduce the number of panels you can fit on the roof, affecting the system's size. So these panels were installed on a flat roof. So this is called a parapet or a retainer wall. Most parapets are between 24 inches to 36 inches. Some of the older homes have them down to 12. But typically, they wrap around the whole house if you do have one of these, which means that you're never going to see these panels. So this is like a 212, so it's virtually flat. We're able to install it as a flat roof system on this one, but it looks great. The customer doesn't have an issue. And because of what we actually were able to do, we were able to figure out like, hey, we want this azimuth, we want this tilt, and we were able to design the best system for the customer. You can probably see some chopping back there. You guys will understand why that's there in a second. If we were to install it here, this is what we mean by the slope of the roof for the azimuth. It's going to be facing that way instead of this way, right? Number one. Number two, the pitch of the roof. Well, that pitch is a lot steeper than the pitch of these panels, which means that installing here might have yielded less production, which means they may have needed an extra panel or two to get the same amount of production in kilowatt hours as we got with this system here.
So Chris, with that roof in the back you just pointed at, it could still be a flat solar thing, correct? It doesn't have to.
It goes right there. So because you will get customers say, I don't want to see it like that. That's fine. We can use that over there. We can actually still install it flat on here. But because we're not getting the optimal tilt for the direct sunlight, we may need to add a couple of extra panels to reach the right amount of kilowatt hours. So we can always compensate by adding more panels. But if they're about saving money and they don't care about the aesthetics, great. They still look good. It's not an issue. We're going to make sure the install is clean. So this is one that would be prior to turn on when we haven't finished landing all the panels. So let's take a look at what the customer means by, are my panels going to stick up? This is what they're worried about when they talk about that, because they've seen their neighbors who all have a normal, just pitched roof with them. They don't want to see it to where the panel is going to be, where the racking is going to be exposed like this. This is what they're concerned about. We can do that. It might only be 1 or 2 panels less by doing that. So in most cases, it's not worth it for the customer to worry about the aesthetics. So by a standard, we don't build them like this if they have a pitched roof, because it's a more attractive and more eye-catching and more appealing look to have it flat on the roof than have it stick up like this. Okay. This is what most customers are worried about. Because of the efficiency of panels have increased, we can lay it on this and get virtually the same amount of production, just maybe add an extra panel and we'd be just fine. Okay. So here's another part about tilt that's important. So we're talking about how it casts a shadow. Too close, it's going to cast a shadow. Well, look at the distance between that. Probably could have brought it just a little bit closer and we would have more room. Because they do cast shadows, we want to make sure it's at the perfect point so we can utilize every inch of that flat roof and not leave too much space in between. So yes, we do have stuff that automatically does all this for us, but all of our project designers go through and double check and make sure that the numbers are accurate before they send you a proposal. Most of your managers are still gonna go in there and do that too. So why is this tilt different? Well, it's because it looks good, number one. Number two, they have a pretty good production for year round. So this layout would be more effective for year round production than a lot of other solar installs. So the installer did an amazing job on this one. That was designed great and it looks fantastic. So depending on the position of the sun and time of the year, each different tilt will deliver different production, creating a more effective solar installation. So we can do stuff like this, and I do stuff like this all the time personally when I sell solar. So if we take a look, it's called the angle of inclination. So here's what we were talking about earlier throughout the year. So let's say in December, they need a 23-degree tilt, but then in March through September, they need 47. And in June, when the sun's at its highest, they need a 70-degree in order to catch the most sunlight. So we're going to take a look and say, okay, 43 degrees is going to be the optimal throughout the year to be able to collect all that sunlight. All right, so this is exactly what I'm talking about.
How big a system is that, Chris?
This one, these are probably 400-watt panels, 2, 4, 6, 8, 9. So 18, 2, 4, 6, 8, 10, 20, 21, 23, 22, 20, 21, 24, 42. 16.8.
That's beautiful.
Yeah.
That was a nice paycheck too. It looks fantastic.
Yeah. I don't know. Well, with that water feature and all that, I wouldn't doubt that that's a 16 kilowatt, 17 kilowatt system. Likely it looks like those might even be 350s. So, yeah, 14 to 16 kilowatt system. What questions we got, guys?
Okay, I have a question. If you have a 8-pitch roof and it's only facing east and west, can you still put solar panels on it?
Oh yeah. We can still put solar panels on the north side of a roof. We just have to add more to equal the same kilowatt hours.
I'm talking about if it only face east and west. What if the
Yeah, that's fine.
Like- can?
Yeah. I may split it up so that I have half the panels on one side, half the panels on the other. So that from sun up to sundown, they get direct sunlight on some portion of a panel, not just because when you see them just on one side. Like I had a customer the other day, I offered to do that. They said, no, I only want it on this side because I don't want it visible on both sides of my roof. Okay, that's fine. I do have to add a couple extra panels to make sure that we're getting the most. That's fine with me. I don't care. I just don't want it visible from that side of my house. Not a problem.
So it's just getting less sunlight. So you just got to put in more panels to kind of make up for that less sunlight.
Yep. Because
That's
the
all.
direct sunlight's going to produce the most. That's why you see an 8 kilowatt system would produce 14,500 kilowatt hours on some, but the same 8 kilowatt, but you need on a split roof to produce on a east to west, you might need a 8.7 kilowatt system to produce the same 14,500 kilowatt hours because the sun factor changed. So I'll show you guys that in one of the modules here in the overview on how we calculate that with peak sunlight hours and stuff like that. Any other questions for me? And guys, if I look away, I'm not ignoring you. I'm ADHD, so I'm always doing something. Like right now, I'm literally folding this thing. It's just I lost my fidget spinner.
I kind of relate to that.
So I'm
kind of
not ignoring you guys at all. I'm always
I
like
kind of resemble that, Mark, let's say.
yeah. Idle hands. So I'm always doing something. I'm always fidgeting. So I'm severely ADHD, but it's my superpower. So you can ask Brian. I'm always doing something and it turns out being super productive. I won't take medication because then I know I'm going to be less productive. All right, cool. Go on to the next slide. So now we need to learn about shading. Okay. So remember what I mentioned earlier? We can't exactly take a hatchet or a chainsaw and cut back somebody's roof to put the panels in there. Well, it's going to end up causing shading on it too. Not just that it's going to be bad for the customer. We're going to cause some shading. Why is shading bad? Well, it causes a problem for production. Here's what happens. So solar panel shading. Shading a solar cell is similar to introducing a clog into a pipe of water. The clog in the pipe restricts the flow of the water, which would be amps, right, throughout the entire pipe. Similarly, when the solar cell is shaded, the current through the entire string is reduced. If only one cell out of the usual 60 cells in one of the solar panels or in your solar array is shaded, the overall output of your system can drop by 30 to 40%. So much like a clogged pipe or a kink in your hose, if the current flowing through your solar panels is interrupted by a shaded cell, the end output is throttled. Okay, so let's go into more detail about that. Partial shading is no different than shading. Even a partially shaded cell will drop the entire panel production. So one of the main factors that are directly responsible for the degradation of output power is partial shading. Partially shaded solar cells produce less current than other normal cells exposed to sunlight and behave like a reversed bias PN junction. As a result, this dissipates power instead of generating and gets heated. So think about this for a second. If I were to put a kink in my hose and I held it there for too long, but I had a full blast and a ton of power going through, what could happen to that hose eventually?
It could burst.
It could burst, right? Guess what could happen to the cell itself? It would burst. It would die.
It's fry.
If it dies, since we already have a interrupted cell, right? And it's like, oh, here's the kink and a little bit power is going through. What happens if that cell completely dies?
It's no good.
No
Not
good.
working.
No good. Right? So it's another major factor when we're looking at shading. It's like, hey, my neighbor's got all their stuff on their south facing roof. Why don't I? Well, if we look at your roof, you got like 1 million freaking ventilation pipes coming up. We can't put any solar on there because even a partially shaded solar cell would eventually, destroy the cell, which could eventually destroy the panel. And it's going to cause the entire panel to drop production. So a chimney, leaves, debris, birds flying and landing on the panels. A little bit of shade will drop the entire panel production by up to 40%. That's an insane amount of droppage for a single cell, right? That's just because we're introducing a clog, which means that wattage at the very end is reduced. So it's a problem. So wait until you guys hear about that string inverter a little bit ago that Shelly and I were talking about. So we're gonna learn about that here in a little bit and why those, I laughed and I said, nah, we'll never sell one of those.
Chris, what do you use for aerial? I mean, how recent is your aerial shots?
Extremely. I have a neighborhood that just got built 6 months ago. We already got it. We got Near Map, we got Google, we got all of it.
Okay.
So doesn't mean that all of them are like that because it's still, we got some companies that are coming out here with drones on new areas and they use that.
Oh, wow.
Yeah.
That's cool.
So Near Map does a lot of that stuff too.
Cool.
Cool. So here's what it looks like. 100% current and voltage output, 100% flow and pressure equals 100% output. So your wattage is going to be fine at the end. Partially shaded output current directly proportionate to the illuminated area of the cell, no voltage change. So the pressure doesn't change. So this is what I'm talking about as well. When I'm saying, hey, we're having an issue with that clogged pipe because the pressure doesn't change. So now you're just pounding at that cell, right? Boom. Eventually you have a damaged cell. We don't want that. Completely shaded cell is no possible output. It's the same as a cloudy day or being at night. Okay. That's all that is. And next, super simple short module, but I think it gets the point across. If we shade a cell, what happens to the panel? It drops production by how much?
40%.
40%.
40.
Yep. Even if it's a tiny little corner of it, right?
Right.
So it's another big factor that we looked at when we're building out these systems for the customers. So far, do you want to actually build out these proposals?
Yes.
Well, you've already done it for years. We got an old project manager. He knows exactly what I'm talking about. I was like, yeah, no, it's these things can be a pain in the butt sometimes. It's like, how the heck am I gonna fit all these panels? I got 2 3-foot pipes sticking out of the roof, and I got a chimney over here, and I got a tree over here, and oh, there's a lot of birds in this area. There's a ton of bird poop on the roof, and I got to figure out how to make sure that that doesn't get affected as well. So there's a lot of stuff that we go through and make these proposals for you guys. So the reason
We
why
have pigeon, we have pigeon guards, right? We sell,
yeah, critter guards are very inexpensive.
but needed in a lot of places in
A
Tucson.
lot of HOAs require it though.
That's because they have an outburst of pigeons.
Yeah, I think I just did one at like 60 feet that cost like $145. It was nothing.
Not bad.
I do have a question, by the way.
Yeah,
So each panel they usually contain 60 cells
yep, on average.
on average. Awesome.
There's some crazy gigantic panels, but those things are like 6 feet tall. There's no point. So I'll teach you guys about the type of cells and panels and how those work here in a little bit. They're pretty cool. It's pretty cool.
Yeah, our commercial panels were huge.
They're gigantic and they're just,
Yeah,
yeah, you don't want them. Yeah, sure, they're 500, 550 watt panels, but I'm gonna get more out of, half the space.
yeah, it's just a pain lugging them around and trying to lay them and
Yeah.
everything.
Yep. Let's see what time is it. So I've had you guys for an hour and a half now already. Wow. Already beating you guys up for an hour and a half. Didn't even realize it. Let me see where we're at.
That's gone quick. That means you're good.
Yeah, I guess. So we're at 50. Cool. So we're about halfway through. Let's go ahead and take a 15-minute break, guys. Go use the potty, go get a drink of water. I know I need a drink of water. I can start hearing my voice getting raspy.
Okay, we get a break.
I don't think some of us need a break.
Yeah, so it's coming back at 15. So it's 5 my time right now. So
15.
5:15. So
5:15,
yeah, we'll just say we'll come back.
7:15.
15. Talk to you in a little bit.
Okay,
Cool.
have a coffee. Bye.
All right, bye.
So Chris, where'd you go camping this weekend?
Apache Lake.
Nice. Was it beautiful?
Oh, absolutely.
Wonderful. Your family, I bet you were just like, oh yeah.
Oh yeah. Loaded up the camper, took everybody out. It was a great time.
Sweet.
No cell service for the weekend.
Oh God, isn't that the best? You can't get me no matter what.
I actually I was still doing my freak out. Hold on, what if everybody needs me? Ryan and
Yeah.
Vic, like, dude, go, just go away.
Right? Chill out, man. Seriously,
Yeah.
world's not gonna fall apart without you.
Oh yeah, I know.
Yeah.
I go
Easier
through
said than done. Yeah, I
Yep.
get it.
Not a control freak. I just like to do things my way.
When I was a mortgage broker, I literally was in a car accident. I'm like literally, taken to the hospital. I'm on a freaking ass gurney, and they're like, "You can use the phone, man." I went to my broker. I'm like, "Man, okay, you got to lock this loan. You got to lock this one. When you handle this?" And they're like, "Are you freaking serious? You didn't even call your family." It's like, "Yeah, no, this guy, I
Busted
I
my
get
back
it.
in a car accident. I had a giant, it was either a giant AC or an industrial stove. They never told me what it was. I just remember when it was flying at me off the back of a truck, hit the front of my truck and took it out, messed up my back. I went into the office the next morning in a wheelchair. I'm like, couldn't feel my leg. I didn't care.
Nope, I get it. I get it. In fact, it was my mortgage broker and one of my cohorts that actually took me home from the hospital. That actually got me because that's how bad. I know. It was just, when you're doing business, you're doing business.
Yup. All right, looks like everybody's back. Let's do this, ladies and gents. All right, back to the training. That was perfect timing too, because my son, I left my homework in my desk. Oh, your teacher emails it to me every week. So let me get that printed out now that I'm on break. Solar cells. I promised we would learn about solar cells, and that's what we're learning about next. Anybody need any questions answered from before? Let's do this. Solar cells, there's different types of solar cells. They all have the same basic function. You have that transparent layer of glass, and you have all the cells down here, and they're going to convert the power, and it's going to go to the electrical device. That's how it works. Okay. Monocrystalline solar panels, each solar PV cell is made up of a single silicon crystal. These are sometimes referred to as solar panels. Polycrystalline solar panels, each PV cell is made up of multiple silicon crystal fragments that are melded together during manufacturing process. You may see these, them called multicrystalline or polycrystalline panels, okay, or poly panels. So we're going to be learning the differences between mono and poly panels, okay? These are the two offered panels. Just so you guys know, there is a hybrid panel out there called a monopoly. It's not a mix of it. What it is REC is the only company that's doing it right now. Half of the panels monocrystalline, half of the panels polycrystalline. That's all it is. They did it for shading function so that if half of the panel gets shaded, the other half of the panel doesn't get affected. The only reason why they did it. Works good. We still don't use it. So big things to take out of it. Monocrystalline. So let's go back to like elementary school definitions, right? Mono means one. Poly means many. So monocrystalline panel and polycrystalline panel. So let's talk about monocrystalline first. Okay. Monocrystalline solar panels are characterized by their black PV cells with rounded edges. Polycrystalline panels, which means they produce, They have a higher conversion efficiency than polycrystalline panels, which means they produce more kilowatt hours of electricity. If you want to install solar panel system on your roof, but you have a limited space, monocrystalline panels will be more productive per square foot. While they are more efficient solar panels, they're also slightly more expensive because the manufacturing process for single crystal silicon cells are more complex. It is more expensive to make these panels, which means in turn, the panels are going to be more expensive. Give you guys a second on that one. I'll give you guys a simple definition of it. Okay.
Who do you use for mono? Oh, sorry.
Go ahead.
Who are you using for mono?
I'll tell you guys.
Okay.
Yeah. So monocrystalline panels are black. Polycrystalline panels are blue. So if you guys see black panels up on a roof, it's a monocrystalline panel. Okay. Monocrystalline panels are more expensive because they cost more to manufacture, but they are also a heck of a lot more efficient. So think about the poly panels for a second. Polycrystalline solar panels have blue-hued PV cells with straight edges. They have a lower efficiency compared to monocrystalline cells, which means that you need more panels to reach the same amount of power. However, polycrystalline panels also have a lower price since their manufacturing process is simpler. Polycrystalline panels are very durable, but they do tend to last slightly less than monocrystalline panels. They are also affected more by high temperatures, which reduce their productivity on hottest days. Okay. Everybody ever been holding their phone for too long and start to feel it to get hot and your phone starts to slow down? That's all it is. It's the same type of thing. Heat will affect your solar panels. It affects both of them. And we'll explain more about that here in a second.
I got a question first.
Yeah.
So what about, in regards to what you're saying about how the heat or the sun affects solar panels? So what about the sunbursts and stuff like that are created on the solar panels?
So that's more going to be stuff that's, when it comes to mono, we don't have to worry too much about that because of the actual effectiveness and the new type, and especially with the Hanwha Q cells.
Mhm.
We don't have too many of those issues. The polycrystalline panels are a huge issue when it comes to any type of burn.
Right.
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 But that's because of the type of glass that they were using as well.
Mhm. Gotcha.
So we don't see it. RECs, you're probably familiar with the REC, and that was the major issue. That's why we don't use REC.
10-4.
Haven't had that question in probably about a year. So guys, all that is basically, I'll just do it a simpler way. You guys ever seen the old solar panels? They might be like 10 years old and they start to get these brownish spots in them, and they start to kind of have rings around them, and they look like they kind of have a crack in them sometimes, or they have spidered out.
Yeah.
All the same type of stuff. It's the panels from the heat. They start to cause damage to the cells, damage to the glass, a lot of different issues. And that's kind of along the lines of what he's talking about, just damage that can be caused in the actual system itself. Okay. Because the heat coefficients, we're going to talk about heat coefficients. Those have been minimalized significantly.
Is this something that's going to be on the test?
Nope.
Alright.
Nope. Big thing you guys need to know: blue and black. Blue on black. Sorry, ADHD. Here are a couple of things to keep in mind about the cost of solar panels. Monocrystalline panels have a higher cost when comparing to other panels. The cost of the inverters, wiring, electrical, the protections, the racking, and the labor are the same with either type. Because monocrystalline panels are more efficient, you may get a better return on your investment. This is something that I had to add in here recently. Homeowners are eligible for the federal tax credit, whether they choose mono or poly panels. I can't believe I had to put that in the training, but I've heard it come up. There are companies out there, smaller companies, who can't afford mono panels as an installation without having an adder or huge adder. And it's like, oh, you need these type of panels to be able to qualify for the ITC. That is false. Doesn't matter if they qualify. You can still go with that company because they're cheaper equipment. Doesn't affect your ITC. We went ahead and eliminated that objection for you guys, because guess what? Because of Titan's buying power, we don't go through distributors. We go directly through directly to factory, which means we're buying the containers that distributors normally buy to upsell to solar panel companies. And we go ahead and get them for pretty much the same price as they're buying their poly panels for, which means that we can sell tier 1 equipment for relatively the same price in 99% of the cases than everybody else is selling cheaper equipment for. So you're not going to see that happen too much. I actually just saw a proposal where somebody was comparing REC panels, and we were $4,000 less expensive than that company was having for their REC polycrystalline panels. Okay, so we don't make a ton of money on the back end. We give most of that commission to you guys. We drop our prices for a reason. We want to make sure that you guys are making money, the customer's happy. We'll make our money on volume as more and more and more of it comes in, right? We don't need to get rich off one customer. It's not worth it. You guys will see some weird stuff. It's like, man, I just made like $40,000 on one system. Like, dude, what did you charge the customer? They don't care. They just don't care. It's horrible, 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 horrible. And we see it all the time. This is what we're trying to fix. All right. So here's things that you're going to need to know. I went ahead and made you a little cheat sheet. Go ahead and write this stuff down. So the silicon arrangement for a monocrystalline panel and a polycrystalline panel. Mono means one, poly means many. The cost for monocrystalline in general is more expensive, but polycrystalline is less expensive. The appearance, you got a black hue versus a blue hue, which means you got the black panel versus the blue panel. Efficiency, they're more efficient mono panels, less efficient for poly panels. Lifespan, 25 to 40 years on the mono panels. Polycrystalline is 20 to 35 years. We're seeing still average of about 30 years. Okay. Temperature coefficient. You're going to learn this definition next. Lower temperature coefficients making them more efficient in the heat for mono panels. Higher temperature coefficients making them less efficient in the heat for poly panels. Okay. I'm going to step up for 2 seconds and give you guys a chance to write that down. I'll be right back. Sorry about that. Someone ring the doorbell. All right, everybody get this down. Anybody not have it down? Let me ask that question. Who still needs me to keep this up? Cool. Okay, let's learn about heat coefficients. Polycrystalline solar panels have a higher efficiency. However, that does not mean that polycrystalline solar panels are inferior products. You can find high quality solar panels of both types. Here are a few facts about the efficiency. When a solar panel has a higher efficiency, it converts a higher percentage of sunlight into electricity. As of 2021, polycrystalline panels have a typical efficiencies below 20%, while the best monocrystalline panels are approaching 23%. You will need more polycrystalline panels to reach a certain kilowatt hour output per month, since their efficiency is lower. All solar panels, all of them, suffer from a temporary efficiency drop when their temperatures increase, but polycrystalline solar cells are less affected by the heat. Okay. So the temperature coefficient indicates how much solar panels are affected by the temperature. All solar panels are factory tested under the same standard conditions, or the STC, to ensure fair comparisons. So that means you don't have to take a manufacturer's word for it. They've been tested, same conditions as the worst panel that's available. In general, polycrystalline solar panels tend to have a higher temperature coefficients, which means they lose more productivity when they heat up. However, as technology improves, there are now solar panels of both types with similar low temperature coefficients. Some, not all. Okay. REC is probably the best poly panel that you can get. It still doesn't mean that's great. It's still a good panel. And I don't talk trash about it at all. Okay. Solar panel efficiency is not a critical factor when there's plenty of space available. Since polycrystalline panels have a lower price, installing more to compensate for lower efficiencies is not a problem. However, when you have limited space, installing more panels is not an option. So monocrystalline panels will maximize the electricity production in an available area. So I'll keep it up for a second while I answer any questions you guys have about this.
Chris, didn't you say that we do not sell REC?
We don't.
We don't. So,
We can, if the customer specifically asks for it, we can get any panel.
so what would you sell in this place?
I always sell the Hanwha.
You all do Hanwha Q-Cell? That's pretty much your go-to
Yep.
since LG no longer exists?
Yep.
Well, they weren't that
I
good
love the
anyway.
LGs. I loved them. I'm disappointed that they decided to pull out, but you know. they
Well,
pulled out,
Hanwha is a very popular panel. It's not a very expensive panel, but
it's not very expensive, but it's extremely well made and they last well. We don't have a lot of issues with them. Silfabs, I love the Silfabs as well. So we'll probably see an email coming out in the next 4 or 5 months like, hey, so Silfab's a new standard. So we'll see. But we always
What's
have 400 watt is right now the current standard.
the coefficient between a Hanwha Q-Cell and an REC,
It's
one has-
still similar. So RECs right now are averaging about 19, and then you got almost 21 on average for most of the Q cells for the Q peak. It's about 21.
you know anything about Panasonic?
Oh, yeah, I know a lot about Panasonic. I don't think they're worth the money half the time. So we still offer them, but it's an adder. I think it's 25 cents per watt for the Panasonic.
No, I get it. Yep.
I'll double check. I thought I had it. I don't have it. The appearance of the solar cells is a result of the silicon structure, since it determines how they interact with the sunlight and how they are perceived by the human eye. The silicon crystal structure of the monocrystalline cells gives them a black color, while the polycrystalline cells are blue. Both panels have both solar panels typically have long lifespans, while their payback period is less than 5 years in many cases. Solar manufacturers normally cover a 25-year power production warranty, while some brands now come with a 30-year warranty coverage. So you're looking at, a lot of the top tier panels that add extreme adders to them when we go to buy them. We can get those 30 years, we can get those panels, we can get virtually any panel. It's just going to cost a little bit different. Our standard panels are still 400 watt Hanwha Q-Cell, which is still probably about 50 watt higher and a better tier 1 panel than a lot of these other companies are providing out there. I'm seeing on average between 350 to 375. Those are still a lot of the mono panels that we're seeing. Even the Panasonics are doing like 350, 375. And they're good panels. I like them. I think that the Q-Cell are better for the money. Do you want solar panels specific colors? So you might want to think about this stuff. The customer wants a blue panel. Absolutely. We can get them blue panels, polycrystalline panel. I have had a customer specifically request blue. I want blue on my roof. Okay, I will get you the blue ones. Okay. While polycrystalline panels are blue, if you prefer one or the other, you can buy solar panels that suit your taste. It doesn't matter. You may find that, so here's an example of system sizes with it. So let's say we have a polycrystalline panel at a 4x3, okay? That's gonna be about a 300 watt panel in this case. And then we have a similar footprint, 4x3, but it's a mono panel, it's 350 watts, which means that if you have 20 of those, you're gonna have a 7 kilowatt monocrystalline system. We're only gonna have a 6 kilowatt polycrystalline system, okay? So all it is the number of panels times the wattage is going to give you your kilowatt system. And I go more into detail on that in a minute. As a result, mono panels are slightly more efficient than poly panels. They also perform better in high heat and in low light environments, which means that they produce closer to their rated outputs in less than ideal conditions. Give you guys a few seconds. Questions? All right.
I have a question, Chris.
Yeah.
Do we ever do tracking systems?
Yeah, we can get access to a tracking system. I've done it before. Again, it's just a matter.
Are you talking about curb?
No, I think he's talking about the hydraulic solar tracking, right? The
Correct.
racking? Yeah,
Mhm.
yeah, we can get them. We do curb as a standard, just in case you're wondering.
I think.
Yeah, curb is included in our price already. It's not an adder. We think it's just something that should be done, so we just did it. But hydraulic tracking system. So guys, those are those ones that they follow the sun. And we can do those. They're expensive. I think the last one I did was like a year and a half ago. It was $1 per watt adder. So they're not cheap. They're very, very expensive tracking systems. But they work.
I never did that. What about, I'm assuming you do ground mounts?
Yeah, all day long. We can also do structures.
Oh, nice. Do we do the structure itself?
We sub it out, but we have a specific company that we do it for in every territory.
Sweet.
Oh yeah, and the tracking, the hydraulic tracking system, those are only for ground mount systems.
They're for what only?
Ground mount systems only. Putting them on
Oh,
the
that
roof,
makes sense.
they're too heavy. Yeah, too heavy. It would damage the roof. And can you guys all do me a favor? Make sure you write this down. So this will be part of your guys' homework. Brian sent out an email that was requested from HR because not everybody filled out their documents correctly on their stuff. It's gonna have the name, or it's gonna have your address and stuff. So just email them back later. It needs to be done by, I think he said by 7:30 my time. So at 7:30 Pacific. So 2 hours from now. So just do it after training. Okay. I'll let you guys go 5
What-
minutes so you guys can go in and do that.
Hey,
Just respond to
Chris.
Brian.
What?
My email address that I gave both you and Brian, I haven't received emails or any
Check your.
correspondence because of it. So should I just give him a different one? Because I don't know if I'm on that list.
I would check your spam. We probably got kicked in your spam.
Well, I didn't receive an email. However, while we were in the break, I logged in for the first time and it allowed me to log in. However, it's requesting the email again. So what you want us to do that Brian said, email what the information? What do we need to email?
It's in the email. So in your work in your personal email, he emailed everybody.
Okay,
Yeah,
got
so
it.
you're saying that you needed a password reset on yours for the website?
Not me. I was able to log in.
Oh,
The
okay.
only thing is, I was expecting all day to receive an email from the company that would say that you're active. I never did. I checked the spam, but you told me log in with the registration. I did that and it worked.
Okay, cool.
I was able to log in. Yes.
Yeah, and so it's that was, I don't know what's going on with that. We just moved to the new server. So
Oh.
some of the emails aren't being sent out. I think I'll go in because I know I do this stuff too with tech. So I'm the one who originally built the website and I have passed it off for them to manage it. So I'll go in and check to see if there's maybe something that not sending off the, hey, your membership has been approved. So that's kind of what it is. It's kind of like a membership type thing is what it's set up under. But we're building out a new one.
Yes, correct.
Yeah.
Mhm.
Cool.
Okay.
Any other questions before we move on? And then, oh, Shelly, go ahead and direct message Brian or text him your email that you want him to send it to.
Will do.
And your guys' work email is going to be given to you tomorrow. So. All right, cool.
Okay.
I
So
did change the email on my registration just because I wasn't receiving emails from you guys. So I just actually created a new Gmail yesterday and gave you that one.
Okay, cool. Yeah,
Hmm.
that'll work. And you can text it to
that's
me
right.
as well. So guys, I'm going to put Brian's direct line. Don't blow him up too much. 3276. There's Brian's direct line if you guys, if I tell you guys to mess with something, because he's handling all that stuff with HR for me right now. That way you guys don't have to deal with HR because they're fun. They think every mess up is the end of the world, and we know it's not. We're in sales. We all mess up a lot. You guys are gonna mess up.
Oh
"Oh,
yeah.
they don't have this filled out. Okay, I'll get it. Don't worry about it. This is why this is why we don't have you guys deal with HR. We do it for you. All right. Any other questions for me about that previous stuff or getting logged into the app?
So when are we going to be able to
website.
see? Well, I already asked you that one again. Never mind.
Yeah. So just make sure your
Go
website, your username is your pictures are uploaded tonight.
Yeah.
So I'm gonna let you guys go 5 minutes early so you can respond to the email and upload your pictures. Because they're gonna make all the badges and get them sent out tomorrow. So I just need to make sure that those are
Okay.
accessible. All right, let's do this. Inverters, actually one of my favorite things to talk about is the inverters because it helps tie in a lot of this other stuff. And I actually got a couple of different videos for you guys. So we have access to pretty much any type of inverters except for the worst one, which is gonna be the first one we're gonna talk about. So string inverter and micro inverters. Solar inverters are have one core function: convert the direct current solar panels generate into alternating current, which is the type of electricity used inside of your home. What is a string inverter? A string inverter is also called a central inverter. It is a standalone box that is typically installed close to your main service panel and electricity meter. There's typically one string inverter or possibly two string inverters on each residential solar installation. It really depends on the overall solar panel system size, okay, on the solar power size. A string inverter functions in series of circuits. So it functions in series, which typically being 6 to 12 individual solar panels that work in a series string. SMA is a leading manufacturer for string inverters. Okay, so they are still used out there. They're not common anymore, not as much as they used to be, because they still are pretty inexpensive, but they don't work well. Here's what happens when something works in string. Anybody remember what happens to Christmas lights before they went LED? What happens if a bulb goes out?
They all go out.
All of them. So if you have 12 solar panels tied together, guess what happens?
They all go down.
They all go down.
Oh, go down.
Okay. So we don't like that. That's a bad thing. Guess what also happens? We learned about shading. What happens if a part of a solar cell gets shaded? The entire panel, what happens to it?
Entire panel's only working at 40%.
30 to 40% drop in production. So if all those panels are working in a series, which means at the very end of it, it's like a hose. What happens to all 12 of those solar panels?
Yeah.
They all drop production by up to 40% because a bird landed on one of them. It's a problem, right? This is why nobody likes them. So there are some advantages to having them. They're easy to troubleshoot. The main advantage of a string inverter is that you only need one of them to convert the DC electricity from the solar array to AC power. If anything is going to fail in the solar system, it's likely to be the inverter, making troubleshooting relatively easy when things go wrong. Cost of a single string inverter on a solar panel installation is cheaper than installing microinverters. There are less labor hours are required, and string inverters are more affordable than microinverters. Lower probability of a wiring mishap. There are less connections between the solar panels and the string inverter. Therefore, there's a reduced chance that any string inverter setup will be improperly cabled compared to a microinverter system. So there's no in and out. It's just all direct current, all in one string going straight to the inverter. Okay. You can't really mess up the installation on a string inverter system. Okay, unless you just install the inverter upside down, but then it's not going to transfer the power. Downside, okay, compliance with rapid shutdown requirements. If you live in an area which adheres to these regulations, which is all of our territories, for rapidly shutting down your system, additional labor and wiring will be needed to be completed, so your solar system will be within compliance. A rapid shutdown box will need to be installed near the electrical service entrance, and control wires will need to be routed between the string inverter and electrical panel. Since there's electricity flowing from your panels and within the string inverter itself, the inverter has to be disconnected at both of these two different places. Since the cost of adding rapid shutdown requirements to your solar energy system is not negligible, it's important to check with your local codes and ask us which type of inverter is going to work best for yours, for the most sense for you. So here's the deal. Rapid shutdown requirements exist because what happens if power goes back to the grid and the worker's trying to work on it? It's not going to be very fun for the worker, right?
They fry.
They're going to fry. So we can't
Yeah.
do it. It's also for first responders and firefighters. What happens if there's a fire and they need to get inside the house and there's electricity just randomly running through one of the circuits, right? It's going to be a problem. So it has to all be shut down. So all of our territories are requiring rapid shutdowns, which means that there's going to be an extra cost to be able to install a string inverter if you wanted to do that. We don't even offer, well, I mean, we do offer it, but we actually upcharge for a string inverter because we don't keep them in stock. Efficiency and partial shade is a major con. String inverters require solar panels to be wired in series. If one of the solar panels output is affected, the entire series of solar panels is affected in equal measure. This can pose a major issue if some of the solar panel series will be shaded for part of the day. There's going to be parts, like there's going to be some installations where we cannot avoid shading. Customer doesn't want to cut down a tree. There's going to be a chimney that, you know, they're not going to tear down the chimney. Sometimes shading can happen. It's going to drop production on that panel. It's going to eventually cause it to degrade even further. Well, if you have it in a string, you shouldn't install on that system. Or you shouldn't install that system where it's going to be shaded consistently. Otherwise, you're going to have to increase the size of that system dramatically in order to be able to compensate for the 40% drop in production for that array, right? So it can be a problem. I wouldn't recommend it. But we don't use these. So we don't really have too much to worry about. But if you're going up against another proposal that does use them, it's a good thing to know, right?
Yes.
The more difficult for system expansions. To get optimal performance from a string inverter, it needs to be working at near peak capacity. So if you want to increase the size of your solar array at some point down the road, those panels will need to be routed to a separate string inverter, adding an additional complexity and cost. So if we do an add-on system, because we can do add-on systems, I've been asked that a lot, and a lot of people are surprised that we can add on to a system. We just put a new inverter every single time. We just throw a new solar edge up on the wall. Okay, not an issue, super easy to do. And we can size the system the way we need to add on the extras. So we hear people all the time, standard backup until about a year ago. It's actually still pretty standard for a lot of these companies. Gabriel will tell you he was working for another company before I recruited him over. As soon as the second I opened the company, he's like, "Oh, I'm coming over." He was being trained by somebody. The guy literally undersized the guy's system, said, "Hey, yeah, man, it's a 70-30 offset. It's the biggest we can put on your house." They could have put 100% offset if they wanted to. So I just didn't like the guy, so I just did it at 30-70. True story. That's when I called Brian, and we're like, we just need to start a company.
That's terrible. I can't believe you do that because you don't like somebody. You shouldn't be in business.
No, it's not something that is okay with. It should not be allowed. That's why we built the company, for that reason, because stuff like that exists. We would be the company that eventually went down, gave him a dramatically discounted system to try to fix his view on the industry, properly size the system. We would just end up having to throw a new inverter on the side of the house, right? With that being said, we don't touch solar leases. We don't own the equipment. There's UCC filing. There's a lien on a part of the roof that's owned by the leasing company. It's too much of a hassle, too much a headache, and too much liability to the customer to add on to a lease unless it's already paid off. Okay? So no add-on system for leases unless the system's already paid off. That's just standard. Can we? Yes. Is it fun for the customer? Absolutely not. It's a nightmare. Just Tell them that they find out their cash price to buy out the system, and then we can add on the rest of it. Okay, they have to own it. That's just an internal policy now. More cons, they have a shorter lifespan. Warranties are typically only about 8 to 10 years, and they only last about 8 to 12 years. Okay. Microinverters are warranted for up to 25 years. System monitoring is you can check, you can see what your system is producing as a whole, but you can't see each panel individually and what it's producing. Okay. There we go. So while aggregated solar production is viewable, you won't be able to see if there's any individual panel performance problems that would be caused by cracks, debris, or defects in the actual system itself, like burrs, right? Give you guys a second for that. Now, microinverter systems. What is a microinverter system? Microinverters perform the same basic function as a string inverter, except they're now installed underneath each of the panels behind on the roof. And they're about the size of an internet router. The biggest difference between the microinverters and the string inverters is a solar installation with the microinverters typically have the same number of microinverters as they do solar panels. So if you have a 34 solar panel system, you have 34 microinverters mounted to each of the back one. Why is that good? Let me have Enphase tell you guys.
Solar panels make it the glory.
We don't have any sound, Chris.
Yeah. Without. Start again, please. Again, design the bicycle. Go ahead.
That work?
Solar panels may get the glory.
Yes.
But it's the inverter that does all the work in a solar PV system. Tucked beneath each solar panel, microinverters are responsible for converting the direct current produced by your solar panels into alternating current your home can use. With such an important role in safety, efficiency, and reliability, it's no wonder homeowners insist on using Enphase microinverters. Enphase is the world's leading supplier of solar microinverters with 940,000 Enphase systems deployed to more than 110 countries. The newest advancement in inverter technology, the Enphase IQ7 microinverter, is a powerhouse. It is available in multiple configurations, engineered to meet the needs of residential and commercial systems. Don't let the lighter and more discreet form factor fool you. With the IQ7 microinverter series, you get consistent high-power production, even when panels are shaded or soiled. That's not all. The Enphase microinverter burst mode helps produce energy even at sunrise and sunset. Now that's powerful. The IQ7 microinverter is proven safe and reliable thanks to more than 1 million hours of testing and an all-AC design that eliminates dangerous high-voltage DC on your roof. And in the event the grid fails or spikes, the IQ7 microinverter allows for rapid shutdown to prevent your solar PV system from energizing the grid and risking the safety of others. The advanced performance found in an Enphase IQ7 microinverter can even help with aesthetics. By producing more power, you can choose to install less panels, which can provide a more discreet rooftop installation. It is also easier for your solar installer to install and maintain. Are you looking for a complete home energy solution, including battery storage? That's not a problem with the Enphase IQ7 microinverter. The modular and flexible architecture of the Enphase IQ7 microinverter has been designed to support system expansion and storage solutions available today and in the future. Choosing the best inverter technology is one of the most critical decisions to make when going solar. By choosing Enphase, you be assured that you've made the right choice.
So let's talk about that. Pros, rapid shutdown capability. New electrical codes require rapid solar system shutdowns for first responders and firefighters are safe from high voltage when they need to be on rooftops or servicing the power lines. Microinverters comply with these rapid shutdown requirements and have the capability embedded in each module itself. more electricity. The core advantage of using microinverters is theoretically you can yield more solar electricity. The reason for this is because there are slight differences in currents between each solar panel, which would be like a shaded problem, right? When solar panels are in a string, the current is reduced to that of the least producing panel in the string. And the other pros, suitability for challenging installation conditions. If the solar system is facing multiple angles, meaning some panels are facing south, some are east, some are west, which would be the azimuth, microinverters are the way to go. Or if you have shading issues from trees or large chimneys, microinverters again would be the best, okay? In these situations, solar panels will be producing different amounts of electricity at different times of the day, but microinverters will ensure you're harvesting all the energy, while with the standard inverter, you'll lose some of the production. So I'll let you guys write that down, and then I know some of you guys probably have a couple of questions.
Does your design team pick which Enphase microinverters they're going to use depending on
Yep.
The size, etc.?
Yep.
Okay.
And if the customer is requesting like, hey, I absolutely want to have the microinverter, cool, we can do that too. Just don't recommend it. You guys will find out why here in a second.
Question, Chris.
Yeah.
So they mentioned about battery banks. Do we offer customers battery banks?
Yep. I think we're gonna have time to learn about that today too.
Okay, awesome.
If not, we'll learn about it first thing in the morning, or not in the morning, first thing at 3:30 tomorrow.
And is that additional to your sales, or is that a part of it?
Nope, it's always more.
Cool.
Yep. Cool. I think main core functions you guys got on this. There's more pros. The lifespan. They typically 25-year warranties. Typical inverters have 8 to 12. Remember that. The reliability of microinverters was in question several years ago, which is why I don't like them. But the technology is now caught up with the industry, and their long warranties on microinverters show the confidence in manufacturers have in their products. This is a direct quote that I got from Enphase. I still question them because they still have a lot. I still see a lot of service work going out on new microinverter systems. They're good. Don't get me wrong. They still work just as fine. The warranties cover the replacements and all that other stuff if they do come up. But personally, I've seen too many problems with them. I've never seen them light a house on fire, so you don't have to worry about that. But this is all. There's also a couple other things I'll show you guys in just a second. One of the greatest features is panel level monitoring. Microinverters and the add-on optimizers allow for the ability to track the production of each individual panel, while a standard inverter, you can only track the production as a system in a whole. Okay. Now, system expansion is ease. If you were to expand your system in the future, you just add an inverter, microinverter right to the back of the panel. It's that simple. Okay. So every time you add a panel, you add an inverter. It increases the cost. So I know there's a lot of words on that one. That one's simple. If you want to add a panel, add an inverter. Here's another one. The main disadvantage of microinverters is the price. They're typically $1,000 more expensive than a string inverter system on a standard 5 kilowatt residential solar system. The cost can increase, and they still do increase. Not can, it will increase. Okay. Maintenance. If one of your microinverters were to fail, not only would be detecting which one has failed be a challenge, but once you did, servicing the panel and the components is not as easy as plopping out the string inverter on the side of your house. The your solar install would need to get up on the roof again, work on your racking system, unbolt the solar module, and replace the microinverter to reestablish the AC conversion capability. And the absolute worst one, the amount of hardware on your roof. Since there's microinverters attached to every solar panel on the roof, there's a lot of expensive metal equipment up there. You're also dealing with a lot of electricity handled at the roof. Microinverters can act as miniature lightning rods. If you're in a storm-prone area, you have a historical wooden structure with shake metal roofing materials. You might want to think twice before installing this on the roof.
Ooh,
So there's definitely some disadvantages to converting power at the roof itself. Okay. So I'll leave that up for a few more seconds.
Okay, I had a question about the maintenance on it.
Okay.
On the pros, you said it has panel level monitoring, but then you said on the maintenance, like you would have to detect which one failed. Wouldn't that panel level monitoring like help you detect which one failed?
You would think so. There's kind of an issue because of the wiring. You can see that the panel is working, but there's a problem with the actual production itself.
Okay.
Yeah. It's one of those catch-22s type things. It's like, yeah, you can see every panel. Yeah, the panel's working, but the inverter's not working. Okay, which inverter was it? Okay, so I got to track down the panel. It could be a wiring mishap. It could be one of the wires that are configured to a different spot. There's a lot of wiring involved when you do a microinverter system. So that was actually a surprise to me when I found out a couple years ago that that's actually a thing. And it's because of all the different wiring configurations. Sometimes it could just be a misread, because you're converting power at the actual panel.
Okay, so just the panel level monitoring is just the panel, it's not the inverter itself.
Right.
Okay.
Okay. So, what is the power optimizer? So power optimizers, microinverters convert DC to energy to AC energy right at the panel site. While power optimizers are located behind a solar panel, they don't convert the electricity on their own. Instead, the optimizers condition the DC energy and send it to a central inverter that finishes the conversion process. The microinverter gives you much more flexibility with your system design. You can build an array in a partially shaded area or split strings across across a usable space on your roof. Optimizers ensure that you get the most production out of each panel in your system, and they allow you the same basic functionalities of both systems. It's awesome. This is why it's everybody's favorite inverter, and I'm going to go ahead and let SolarEdge tell you why. They kind of took over the market a couple years ago, and this is becoming the standard for solar installs. It's amazing.
A photovoltaic system consists of PV panels, which produce DC power when exposed to sunlight, and an inverter, which inverts the DC power into AC power that is fed into the utility grid. 3 different inverter topologies are currently used in PV systems: a traditional string inverter system, a microinverter system, and the SolarEdge solution. The traditional string inverter topology, which is still used in the vast majority of all installations, has a number of significant drawbacks. In traditional systems, panels are wired in a series as a string. Since each panel has a unique power production profile, which is a function of differences in manufacturing variances, installation parameters, and shading patterns, the entire system's output is limited. The traditional system design requires all strings to be at the same length, using the same type of panels, and to be positioned at the same angle towards the sun. Real-life installation constraints result in either wasted roof space or unnecessary duplication of system components. The DC cables which connect the panels to a string carry high voltage as long as the sun is shining. The traditional inverter cannot shut down the panel's DC voltage, and therefore poses serious risks to installers and firefighters. A traditional system cannot track power output, temperature, or any other parameter of a single panel. This makes it impossible to identify specific panel-level problems remotely. In the 90s, another inverter topology was introduced. the microinverter. This topology takes the functionality of the traditional string inverter and scales it down to fit a single panel. By controlling each panel individually, microinverters are able to solve certain challenges of the traditional system. However, microinverters have their own inherent drawbacks. This topology requires each panel to have its own microinverter with full inverter functionality. Therefore, it has significantly higher upfront costs relative to traditional inverter topology. When we started to develop the SolarEdge solution, we defined 3 goals: to optimize power generation of each panel individually, to use the same installation methods and components used to install traditional inverter systems, and to compete with the cost of such systems. Eventually, we developed a topology that meets all of these goals. The SolarEdge DC optimized inverter topology combines the best of both worlds. Our solution splits the traditional inverter functionality into 2 products, the Power Optimizer and a simplified inverter. The Power Optimizers are located on each panel, turning the panels into intelligent panels. These Power Optimizers provide panel-level tracking and real-time adjustments of current and voltage to the optimal working point of each individual panel. The simplified inverter is installed similarly to a traditional inverter, but it is only responsible for DC-AC inversion and grid connection. Our solution includes 2 additional features: a panel-level cloud-based monitoring platform, which is accessible from any computer or handheld device, and an enhanced safety mechanism. When installers install the SolarEdge solution, they use the same cables, connectors, and methods as used in traditional systems, and are able to install more panels, to combine long strings with short strings, and to install panels on different facets of the roof. The SolarEdge cloud-based monitoring platform provides full data at the panel, string, inverter, and system level. This allows for immediate fault detection, real-time alerts, and comprehensive analysis. These important features reduce operation and maintenance costs. In addition, we have incorporated panel-level safety mechanisms to protect installers, electricians, and firefighters. With the SolarEdge solution, whenever AC power is off, the string's DC high voltage is automatically reduced to a safe voltage. This solution meets new safety regulations in all significant PV markets around the world, as well as the 2014 National Electric Code in the U.S.
Bah. You guys see what's everybody's favorite inverter?
I like it.
We take the pros from the SolarEdge, or from the microinverter, and the pros from the string inverter system. We put them together. What eliminates a lot of the cons. So that's the beauty about the optimizers.
A photovoltaic
What you guys got for me? Questions?
No.
Anybody's brains feel like they're gonna explode yet?
Oh, yeah.
Oh, you guys, a lot of information.
She's like, mine's already
Yes.
melted.
Yeah.
Shelly, a lot more information than you've ever seen any other solar company give, right?
Yes. That's right.
This is, and this is the biggest part of the training for you guys. I was able to condense it down just into the definitions for you guys. I spent a lot of time doing this because I want to make sure that we can relate that to the proposal, because that's what your guys' job is, to deliver the proposal. Okay? So there's a lot of stuff that you guys aren't going to have to do, like this next section. So let me show you. Here's how we do system sizing. Okay, super simple for us, super complicated if you haven't done it a couple times. Okay, this is why we do it. We don't have you guys do it. We want to make sure that you guys are focused on your portion of it and not on trying to build these systems. So this will not be on the test. I will repeat, this will not be on the test, but this will help you guys get a better understanding of a lot of these other things that I talked about earlier. So what you guys need to do in order for us to properly size the system is figure out how to properly size your system, take the kilowatt hour energy requirement to divide it by your peak sunlight hours to get the kilowatt hour output. Then divide the kilowatt output by your panel's efficiency and get the system size for the number of panels that you'll need for your system. You guys get a picture of the graph on the bill, or you get the annual kilowatt hours, or you get the monthly kilowatt hour consumption. It's always better to have a monthly or the graph. And here's the reason why. You see how this spike happens right here from June or from July all the way through October for this customer here. This tells us when we're going to need the most power so we can set the proper tilt for the customer. Okay, this is one of the functions that we need in order to be able to do it. So check this out. We're now going through our overview to put some of the stuff together. Here's our formula that we use. We take that annual kilowatt hours divided by the peak sun hours to get the system size. So let's do an example. So 14,500 kilowatt hours. Let's say the peak system size or the peak sun hours are going to be 1.7 is going to be the factor that we're using, because let's say it's at 180 degree azimuth. Okay, so we took that information, been there based off the geographic location, based off the tilt that we're going to be using for that system, based off the sunlight hours that are going to be available for that. And then we go ahead and also based off the azimuth, and we figured out it's going to be 1.7, gives us an 8.529 kilowatt system, or 8,529 watt system. So system size divided by panel wattage equals the number of panels, which means 8,529 watts divided by 350 watts on this panel would be 24.116. Bonus points, you guys haven't been caught, but do you think we round up or round down whenever we do system sizing?
Round up.
Round up. We're going to round up the number of panels to the next number. So we'd be using 25 so we can get the true system size that would be best for this customer. 25 panels times 350 watts equals 8,750 watts, or which would be an 8.75 watt system, 8.75 kilowatt system. Okay. System size times the peak sunlight hours equals a produced kilowatt hours divided by the required kilowatt hours equals the offset itself. That's a lot of math that you guys aren't going to have to do. Okay.
So Chris, do you guys actually go 15 or 20% above their actual usage to offset a, future usage?
TEP only does 110% actually. So now I'm only at like 4 different companies that I know that will do over 110% offset. So we do this 110% offset as a standard,
Okay.
between 103 to 110, depending on, what we see on the actual monthly usage. Okay.
Okay.
So we can always add more. It's questions that we ask inside the house with the customer, and I'll show you guys that on Thursday. So we can add more systems, but it's all based off the customer itself. So for this one, 8.75 or 8,750 watt, 8,750 watts divided or times the peak sunlight hours, which was determined by all that other stuff, 1.7 equals 14,875 kilowatt hours is going to be produced, which is 14,500 kilowatt hours, which is what they were using, is going to be 102% offset. So in this case, we're going to be producing just with one extra panel, 2% more power than we need for that customer, right? Than what they used prior, which gives them a little bit of wiggle room for some sunny days and stuff like that, right? If they want to drop their temperature by an extra couple degrees every single summer, well, we're going to need to add an extra panel or two. If they're going to add an electric car, if they're going to add a pool, if they're going to add a hot tub, if they're going to put a room expansion, if mother-in-law is moving in, if father-in-law is moving in, if the kids are moving out, we might need to take some panels off. So these are all things that we figure out in our consultation so we can properly size the system, not just for now, but for the future. Quick example. We have a customer. Really cool lady. She works at Raytheon. She bought the house for her son. Okay. This is one of my referrals, one of my realtor friends who's now being cross-trained in solar so he can sell through Solar Panel Pro and become Solar Panel Pro certified, referred somebody over to me, and I went and sat down with her. In 3 years, she's going to be building a pool, a hot tub, heat it all. She's getting an electric car for him. She's just making him make sure he's set up for the rest of his life, right? Really cool thing that she's doing. But every other company was sizing the system based off of all of her needs if she was going to be staying in that house for the next 20 years. In 3 years, it's going to just her son. He's not married. He doesn't have a girlfriend. He's not planning on it. And it's not going to be needed. So it's like, okay, we'll oversize it a little bit just in case that stuff does happen. But they were trying to sell her a 13, 14 kilowatt system. Worst case scenario, if her son does get a wife and a kid, and they have the electric car already, great. It's only going to be maybe a 10 kilowatt system. So we did 10.4 on the projection on a new build. All she actually needed based off of the usage for just him was just going to be 8.4. So we also
did you consider that? Now, has she already put the pool in? Has she already put the electric car in?
Brand new build, didn't even have. So we're considered new construction specialists. I do a whole different training with these guys. We have a lot of different stuff because we figured out the exact kilowatt hour usage is going to be for the pools, for the heaters, for the heat pumps. She didn't even have the fridge that she ordered in yet. She didn't have the washer and dryer in yet. She only had half of a month's production. So we pushed out her install by 3 months so I can get 2 more bills in the meantime, so we can figure out what her production is going to be.
But you do consider the pool and all the new stuff that she's going to add into her system.
Yep. So it was 13.6 kilowatts if it was still going to be her and her 2 other kids inside the house. Since it's just going to be her son in 3 years, it's going to take her 1.5 years to build the pool. It's going to take her, she's not buying that electric car until after she's getting ready to move out. She's not even going to need all that. 10.4 kilowatts is all she's going to need for the pool, for her appliances, and for the 3 people, which means when it goes down to 1, he only needs an 8.4 kilowatt system. So we just landed on the 10.4. That way, when he has a kid and a wife, it's already expanded out to that point. We can always add panels onto a system. Not even told of that. We can do it based off of what he's going to need for the next 10 years of his life on his life plan. And then when he decides to have a kid and a wife and he wants to expand his family out, he can go ahead and add panels then. Is he going to need them for the next 10 years? No. Right? So why oversize the system and charge them more money on a bigger system? She fell in love with it. We were actually only 10 cents per watt more expensive than another company because they found out I was coming in and they tried to cut the bottom out of it. She still went with us. So I ended up, we ended up doing a price match anyways because it was similar equipment. But you guys will see that too. You'll see companies just try to bottom it out. It's like, oh crap, Solar Panel Pro's going in there. Let's just cut out all the profit that we were going to put in there because we're trying to change that. There's no point to sell $5.50 per watt on any system, let alone a 10 kilowatt system. That's ridiculous.
Depends on if she wanted to use the tax credit as well. I mean,
it's going to depend on the customer and what they're going to use for the tax credit, but the utility company only buy back up to 110%. And in 2020, the Fed started cracking down pretty significantly on the ITC. So I'll explain that to you guys because I found out about the crackdown going on. There's some crazy stuff that's happening. So we got to make sure we're sizing these systems appropriately for the customers no matter what. Because the customer is the one that gets audited, not us. It ends up being the customer who ends up getting in a lot of trouble, not us. And that's not fair to the customer. So there's that. So here's a real customer, copy of her proposal. So let me go ahead and show you guys. So this is the proposal that's currently being used. It's cut off because I'm in PowerPoint, but there's usually stuff that's right here, including their annual or their property value increase. Okay. So we show the average electricity bill is $245 for this customer. There's an average annual increase every single year for utility companies, average of 4%. Arizona has an average of almost 7% right now. And back in 2016, utility companies were given permission to increase the average utility bills in Arizona by $8.90 a month on average. Okay. Other utility companies, they didn't get that type of permission, but they still increase on an average of about 4%. So in 4%, do you plan on using the exact same amount of electricity for the rest of your life? No. Do you use the same amount of electricity that you used when you were 18 years old, moved into your first apartment? No, it doesn't happen. You're going to end up using more. If you use the exact same amount of electricity in 25 years that you use today, you're going to spend $653 a month for the same amount of electricity you were spending $245 for. Right now, spending $3,000 a year in electricity, you're going to spend almost $8,000 a year in electricity in 25 years. It's $122,000 in electricity is what you're going to be spending for renting your power for the next 25 years. But then it doesn't stop there. So if there was a stopping point, look at all these savings that you get, right? So it's just like renting a house. You can rent your house the rest of your life until the day you die, or you can put a stopping point on it and finance it for a couple of years and have that turn off. Then you have some green savings here, and then you have your property value increase. I think it was like $38,000 for this house. So this was a 12.8 kilowatt system, brand new construction. This was May's house. This was her neighbor. They ended up buying as well. So looking at 20,000 kilowatt hours is what's needed. They need a 12.8 kilowatt system in order to do it. We have a multiple azimuth, right? So we have all these different arrays on different azimuths. We're using SolarEdge. We're just going to do the SolarEdge 10,000 on this one. We're not going to do the 2. I don't know who the solar proposal writer was on this one, but I just haven't left it yet. We've already upgraded to the 10,000. The Hanwha Q-Peak Duo Black, the 400s. We use 32 of them on this house. Here's that energy increase. And then here's how their actual usage works. So here's their production when they're producing more power than they're using. Here's where they use their bill credit. So anything over the orange line is where they would use bill credit or have additional bill from the utility company if they didn't have enough stored bill credit. Here's where they would gather bill credit because they're producing more than they're actually using. So this is where that tilt and azimuth and all that stuff comes into play when we're trying to figure this stuff out. This is why we ask you guys to make sure that just because you have the annual kilowatt hours doesn't mean it's going to be an exact prediction. We can do better when we have the monthly, and we still require you guys to get a copy of the utility bill before you can even submit it for a bill. This one's going to be 8% more offset, so 108%. So she's going to produce 8% more than they need. She was at the $245, and it's only $90 a month. On payment 18, if she reinvests all the tax credit that she qualifies for the $14,000, it's all based off of tax liabilities. I'll explain more about that on Thursday. If she reinvests all of it, it's at $90 a month. If she does, and then she goes on payment 19 to $174, and she stays flat there. There's usually a checkbox. It's not showing me because of where we're at on this, but you can uncheck these and it shows it. It went to $224, I believe. But on average, it's $5 for every 1,000 times 15,000. Whoops.
In the new software, you said we can just click it to show them if they don't use the tax credit, if they decide to go on vacation instead of what the payment would be.
Yeah. Well, even on this one, you could still do that. But just because I'm on PowerPoint and I have this one app that lets me display the web page, it's displayed. It's actually a bigger version of this. You can't even see the qualify button that's right here. It squished it. That's all it did. Let me see if it'll let me know. It's not gonna let me zoom out. Okay. So yeah, there's that. And then we can show it. So the loan amount on this one was $54,000 with the tax credits. She's ending up only paying $49,000 for the entire system, which comes out to be a huge savings, which is not showing, but it's over $70,000 in savings is what she's saving on this.
Mm-hmm. And is Arizona still doing the state tax credit of $1,000?
Yep. And these are automatically based off of the address that you punch in. It says whether or not your state has a tax credit. Okay. But yeah, that's it. And then we show them their 7 steps, and then it has all this in there. So if we need to email it out to them, if they don't choose to go right then and there, then they can do that too. Okay. So there's that. There we go. We're gonna learn about this later. Okay, so couple of pros for homeowners. Okay, property value increase. So if a customer ever wants to sell their house, they can. Property value increases pretty significantly. So on that one, you saw it was roughly about, it was $40-something thousand is what it was increasing. Okay, almost the entire system cost post tax credit. Homes with purchased solar sell up to 20% faster. Great value proposition for the new buyers. better feature on the MLS. And actually a lot of realtors are starting to learn, especially down here where we're working with the realtors. We're working on global expansion on that as well, trying to get all of our territories to have realtors that are bringing on, or at least cross training their realtors so that they stop dogging solar because they just don't know. It helps with the affordability objection when somebody's looking at a house. I just don't think I can afford the electricity on the house this big. Oh, it already has solar. And it creates urgency to your buyer. You can transfer the loan directly to the new homeowner when they purchase the house. The current person who's selling the house doesn't even have to deal with it. The realtor deals with all of it, and we help with the transfer, the warranties, and all that stuff on our end. Okay. And it creates urgency because they sell faster. You can sell your home faster and you'll get more bids, and you can help create bidding wars. So according to a recent Zillow report, homes with solar panels sell on average 4.1% more than comparable homes without solar across the United States. This includes leases. A study conducted by Lawrence Livermore Berkeley Lab also found that homes with solar panels tend to sell slightly faster than homes without. A consumer guide from the U.S. Department of Energy states that solar electric systems raise a property's value increase by $20 for every $1 in utility saved per year.
And Chris, on the transfer, do the new homeowner have to qualify?
Yes.
Is there any exceptions to that? Or did they do away with that?
That's why we do sub 650s or sub 650s now. So I've seen some of the FHA at 580 get approved, but it's not a standard. There's going to be a lot of different variables in there. It's still pretty much the same qualifications as you get most home loans. So another option, and we had a realtor do this recently because I mentioned it to him, and they said, "Oh, you can't do that." And yeah, they were able to do it. Just rolled it into the mortgage. If there's room inside the mortgage, just roll it in the mortgage. You got your property value increase, and then when you get that roll into the mortgage, you just pay it off as a seller when that comes in. The finance company gets their check cut by title. They don't even get to touch that money, and now the customer has a paid off system that's rolled into the mortgage. You do the same thing with the lease. Most cases you can do it with the lease. Not all cases, very different circumstance. If that comes up, just let me deal with it and let Brian deal with that. Not even an area manager is allowed to have that conversation with the realtor. It's just me and Brian because they're very touchy subjects on leases. There are times where leases will not allow you to transfer or to pay off the system and then transfer it over. They won't honor the warranties. I actually saw that one recently as well. So you got to make sure you give them the right information. Let us deal with that because we're handling all the realtor transactions. So if you are a realtor in here, or if you know a realtor and they ask you, just give them my phone number. I will help them through the transfer process personally. Okay. So one more thing I want to cover before we move on. Then tomorrow, I'll let you guys go for the day. And tomorrow we're going to start bright and early with the solar storage. So 3-day right of rescission. The right of rescission refers to the right the consumer has to cancel certain types of loans. We fall in this category. It's typically for like refinancing your mortgage and stuff. So it helps customers. It gives them a cooling off period after you sign loan docs because people do buy off of emotion. They don't buy off of logic, right? So it gives them that opportunity to do it. I train you guys how to properly do this so that you don't shoot yourself in the foot, but we show it to every single customer. And on our welcome calls, we ask the customer if they were shown their right of rescission or explain to it. And if they weren't, they freak out and they will cancel on you. Okay. So it's better just to go ahead and let them know that they have it. I haven't had a cancellation for years. Okay. But it's all based off of the conversation that you have with them and how you explain this stuff. The right of rescission is a legal right that allows a consumer to cancel certain types of loans, such as refinancing, home equity loan, home equity line of credit, or HELOC, and even some reverse mortgages. It gives the 3 days to rescind the agreement to get your money back or to cancel with no penalties in these types of cases. Solar loans fall underneath that category. It's super simple. So we're going to go ahead and give you a 3-day right of rescission here so you can cancel the contract if you felt you were forced into a pressure to get in something you didn't like, want, or need. You do like solar, you do need solar. Cool. I don't like to have to come back. If you have any questions or doubts about it right now, now's the time to ask me and I'm happy to answer those questions for you. Most customers cancel because they weren't given the option or felt like they were trapped. That's really what it is. And we will help you guys save that if it ever does come up. It's very rare. We have a retention rate of over 93%. And we're going to continue that. It's actually rising still. I think we're closer to 95% now. We don't have very many cancellations. Okay. Other than that, yeah, don't be afraid of it. So you guys will have a copy of this cheat sheet in your document library, which you'll have access to tomorrow. Okay. Once again, I am not inside of your houses taking the test with you. So if you guys have a little cheat sheet right there next to you, it tells me that you have the information available at your fingertips, so I can hold you responsible for anything you say. That's why we have this test. I can't control what you guys do inside your homes, just like I can't control what a customer does inside their home. I don't care if you guys have your cheat sheet on the test. It's not a big deal to me. It doesn't hurt my feelings whatsoever. It's about knowing the information and having accessibility to it, not having it right at the tip of your head. I don't expect you guys to know all this. As long as you have access to the information and you're willing to tell a customer, I don't know, but let me get the answer for you, and you pick up the phone and call your manager, that's what I care about. There's another section of that you guys are gonna get into. Talks about the warranties and all that stuff.
Okay.
So just for time purposes, I'm not gonna. Any other questions?
Yeah, can you go back to that last slide, please?
This one or this one?
The one with the
The second one.
Okay.
kilowatts.
Yeah, it talks about workmanship warranties and stuff like that. And this is on the standard and on the average. You guys run all of ours on Friday.
So the test is on Friday, correct?
Test is over the weekend. So you have accessibility to
Over
be
the
able to take
weekend.
your test on Friday.
Okay.
But you have all weekend to take it. And you get
Okay.
you can fail it up to 3 times before you have to go back through any type of training. So I tell everybody, just call me if you fail it twice. A lot of times it's just one thing that you're messing up on. And we can usually fix that with a quick phone call. Okay. If you're
Okay.
missing like 20 questions out of it, let's go back through training. Okay. It's okay.
How many questions? How long is it?
It's only 31. It's not that
31.
crazy. Yeah, with the
Okay.
bill review section that talks about bill review, it's separate. It's 10 questions on that one. So 41 questions total.
Okay.
I've already been told we've had everybody pass the first round. Some people took 2 tries, and on the 3rd try, they ended up getting it. Sometimes just because they misread a question or a couple of questions, because there's a couple of them that say which one of these is not a proper definition or something like that, right? They didn't read the does not, and they were looking, they were confused, and they clicked one of the right answers, which would be right. But that's where we're testing. Are you paying attention? Are you actually reading? Or are you just zooming through it?
Those are the tricky ones.
Yep. So make sure you read
Or
everything.
the double negative ones.
Yep.
Okay.
But like one of the questions, I'll tell you guys right now, it says, what is an inverter? It protects the house from Decepticons. That's one of the actual options. I wrote it myself. Another one, what is a string inverter commonly referred to as? The 5th option is Matt Damon. So every once in a while, you guys are going to see some weird something in there. It's just to make sure that you're paying attention, number one. Number two, it's really just because I think it's funny. So I gotta have fun while I'm working too. I gotta enjoy what I do. I want you guys to do it too. But it really does. It like everybody who's ends up seeing stuff like that, they a couple folks, they call me afterwards like, look, I was stressed out until I read that, and then it made the test a lot easier. So I might keep doing stuff like that, and I might go change a couple of the answers to something corny like that, just because, guys, just breathe before you take it. Okay, we give you guys 3 attempts. Our job isn't, our goal isn't to make sure that you fail. It's to make sure that you have the information accessible to you. All these training decks are available for you guys to download and have at your fingertips so that you can go back and cheat inside of a house. Okay, you can look through your notes with a customer. You call us. Do not lie to a customer. Do not fake your way through a conversation. They know when you're lying. Okay, if you don't know, you don't.
Hey, Chris, on the credit, the bill credit, is it still only locked in for 10 years with TEP? Whatever.
Pretty much standard nationwide now. It's a 10-year grandfather rate.
Oh.
So they lock in your buyback at 10 years.
Hey, Chris, for the homework thing, you said log back in, upload profile pic, and put your phone number. What would we put for the website URL? Because it does ask
Copy
that.
paste yours up at the top without the edit button. That's your titanspp.com/user/your username.
Okay.
It's a string inverter is the same thing as an apparatus.
I'm not sure. I've never heard it referred to as an apparatus.
Or like as in like the little machine in the outside.
So the string inverter is just a central inverter. I've never heard it referred to as an apparatus.
Oh, okay.
I could be wrong. It could be different. It's like it could be a different term that I just haven't heard of personally.
Yeah, I think it's just called under the where it's electrical. I guess they put it under like apparatus or something.
Well, it would be considered just an apparatus. It's one of the components of the solar system, but it's got its own specific name. It's the inverter itself. So, I mean, if it's listed under something, it's just a solar apparatus. A solar panel could be considered a solar apparatus.
Yeah, anything can be an apparatus.
Yeah.
That's on the South America, Central America, probably. They use it
Yeah.
that way.
So I've never
Apparatus,
heard it
yeah.
referred to directly as an apparatus before. That could just be, just that's a general term for, a thing.
I think, yeah. Mhm.
But I'll find out. I'll call Titan and see if it's referred to specifically as that. We have a Thos over there is the genius behind a lot of stuff. I love talking to Thos. He should do something every time.
Hey,
I
girl.
don't know everything, guys. Like I'm the first one to say I don't know, but I'll find out. So I'll find out. I'll call Thos tomorrow.
Chris, didn't you say that our workman's warranty was 25 years?
Yep, but typical
For us?
workmanship warranties for other companies are 10 to 20
But on the test, is it going to say the typical or is it going to say ours?
hours.
Ours. So this one here on your list, it says it
This is just
is
for you
10 to
guys.
20 years.
For competition. Yeah, this is just that competition sliding scale. So you know what's standard. So this is what's standard in the industry. This isn't what's offered by us.
Okay, I was a little confused. You're going, wait a minute, we have better than this.
Yep.
I know we haven't covered that yet, but when we do, that's what's going to be on the test. Is ours, not theirs.
Exactly.
Cool.
Okay, cool. Good to know.
All right.
All right.
Yep. Okay. I think that's it. All righty, guys. Thank you for joining me. I hope you guys' brains feel like they're ready to explode because that means that you learned some stuff today. But did you guys already start to notice that as we went over a different definition, it kind of tied back to the other one, made the other one make a little bit more sense?
Oh, yes.
A little bit? Okay. That's going to
Yes.
happen a lot once we actually go through the proposal on Friday. It's going to be, oh, I actually do remember all this stuff. So this is why we do definitions. I know there's a couple folks in here that have, a lot of solar experience. I know damn well they would call me out if I was lying about any of this stuff, but I'm, being pretty legit. When it boils down to the fact that this is basically like right here today is everything you'll need to know about solar. Now it's how do we use it in solar and how do we talk about it in a sales situation? Because you guys don't need to know how to create the proposals.
I was taught years ago that if you learn the definition of any new industry, you will learn the industry.
Exactly.
That is the best place to start, is the definition of the industry.
Yep. And
The
that's why I
definition.
teach by definitions and I don't teach by, just a ton of examples. Learn the
That's
definition. A lot of the stuff was going to end up going over your guys' heads if I went the other route. And I don't want to do that to you. It's not fair. Right? You guys will be at the end of this meeting, you'll be like, oh, that was actually really simple. After like a week or two, as you're gonna say it enough times, you're like, I know this stuff out. There's a lot of stuff you don't know, trust me. But it's not relevant to what your job function is, but you know enough to make sure that yes, us on the back end, we took care of it for the customer. You know enough to make sure that they've explained correctly to the customer. Most of the legality stuff is what we're going to be covering for on Thursday, Friday. Tomorrow is going to be a little bit more of the sales stuff. I want to take a break from some of this, give you guys a little bit of an unwind, because it's one of those situations where if you take a step back from a problem, you end up with a solution, right? So tomorrow we're going to learn more about the advertising functions. We're going to learn a little bit about storage, right? A little bit about the solar edge or the curb. And then we're gonna learn about advertising, give you guys some of those functions, teach you guys how to, do funnels. I'll give you guys some examples of those, get you guys access into your app so that you guys can do watch your bill review on Thursday. And Thursday we go into sales. What are the 5 steps to giving a proposal? And then how do we tie all this information that we learned so that Friday we can go dig deep into it and actually do presentation and teach all that stuff. Okay.
Awesome.
So definitely appreciate you guys. Thank you for letting me ramble on for 3.5 hours. Been told I love the sound of my own voice. So
That's cute.
Yeah.
all right, you guys have a great night. Don't forget to email Brian back that information so we can get it over to HR, get your badges created. Make sure you get that profile picture uploaded tonight, please. If you have trouble logging in, text me and I'll be available just to go ahead and send you a reset password because most of our tech guys are off.
Okay. Thank you.
All right.
Bye.
Have a good night. See you guys tomorrow.
Thank
Thank you.
Bye.